We measure time by light. The tick of a photon defines our seconds. But what if time doesn't really exist? What if the universe is timeless? What then happens to the thing we call light, the very pulse of reality? This question strikes at the heart of everything we think we know about existence itself. Every clock we've ever built relies on light in some form. The cesium atoms in atomic clocks vibrate at precise frequencies of electromagnetic radiation. The pendulum of a grandfather clock catches sunlight as it swings. Even the beating of your heart depends on electrical signals, tiny sparks of electromagnetic energy racing through your nervous system. Light and time seem inseparable, woven together into the very fabric of reality. When we look at distant stars, we're literally seeing into the past, because their light has traveled across space for millions of years to reach us. When we measure the speed of light at exactly 299,792,458 meters per second, we're defining both distance and time in a single breath. But here's where things get strange, beautifully and terrifyingly strange. Some of the most profound theories in modern physics suggest that time itself might be nothing more than an illusion, not just a human perception, but a fundamental misunderstanding of reality's true nature. From quantum gravity to the block universe theory, brilliant minds are proposing that the universe might be completely timeless at its deepest level. This creates a staggering paradox that should make us question everything. If the universe has no time, if past, present, and future are all equally real and simultaneous, then how does anything move? How does light travel from one place to another? How do we see anything at all? Think about this for a moment. Right now, photons are streaming from your screen into your eyes, creating the very experience of reading these words. But if time doesn't exist, if it's just an emergent property of something more fundamental, then what is really happening? Are those photons actually moving, or is motion itself just another illusion layered on top of a static, eternal reality? These aren't just abstract philosophical questions. They're cutting to the core of what physicists are discovering about the nature of existence. In the equations of quantum gravity, time disappears entirely. In the Wheeler-DeWitt equation, often called the equation for the wave function of the universe itself, there is no time variable at all. The mathematics suggests that reality might be fundamentally timeless, with time emerging only as a secondary effect, like the way temperature emerges from the motion of molecules. Yet here we are, experiencing change, watching light move, feeling time pass. If time is an illusion, it's the most convincing illusion ever created. Every photon that hits your retina, every electromagnetic wave that carries information from one place to another, seems to prove that time is real and that motion through time is the most basic fact of existence. To understand what happens to light in a timeless universe, we must first understand what light is and how it connects to time. We need to journey into the strange world where physics meets philosophy, where the most fundamental questions about reality remain beautifully, mysteriously unanswered. To truly grasp what happens to light in a timeless universe, we must first understand something remarkable about light itself. Light is not just illumination, not just the thing that lets us see. Light is the ultimate clock of the universe, the cosmic metronome that beats at the heart of reality itself. Imagine the most precise timepiece ever conceived. It's not made of gears or springs or even atoms. It's made of pure light. This is what physicists call a light clock, and it reveals something profound about the relationship between light and time that will shake your understanding of both. A light clock is beautifully simple in concept. Picture two mirrors facing each other, separated by a fixed distance. Between them, a single photon bounces back and forth, like a luminous ping-pong ball trapped in an eternal game. Each round trip marks one tick of this cosmic clock. The photon travels at exactly the speed of light, covering the same distance each time, making this the most regular, most precise timer imaginable. But here's where things get strange. According to Einstein's special relativity, this light clock behaves in ways that challenge our everyday understanding of time itself. If you were to take this clock and accelerate it to tremendous speeds, something extraordinary happens. From your perspective, watching from the outside, the clock appears to slow down. The photon seems to take longer to complete each journey between the mirrors. This isn't because the photon is getting tired or the mirrors are malfunctioning. This is time dilation, one of the most experimentally verified predictions of relativity. The faster the clock moves relative to you, the slower it appears to tick. At speeds approaching the speed of light, the clock would appear to nearly stop altogether from your perspective. Now comes the truly mind-bending part. What does this experience look like from the photon's point of view? This question leads us into one of the deepest mysteries in physics. According to the mathematics of relativity, a photon experiences zero proper time. From the moment it's created to the moment it's absorbed, no time passes at all in the photon's reference frame. Think about what this means. That photon bouncing in our light clock doesn't experience the journey between mirrors. To the photon, departure and arrival happens simultaneously. The photon exists in a state where time simply does not pass. It is, in the most literal sense, timeless. This isn't just true for photons in thought experiments. Every ray of sunlight that has traveled 93 million miles from the sun to Earth, every signal from your smartphone, every twinkle of starlight from galaxies billions of light years away, experiences this same timeless existence. From light's perspective, the entire journey happens in an instant, in no time at all. This reveals something profound about the nature of light itself. Light doesn't just measure time, it exists outside of time. While we experience the passage of light through space as taking time, light itself is timeless. The photon that left a distant star a million years ago and the photon hitting your eye right now exist in the same timeless moment from their own perspective. Consider the implications of this startling fact. When you flip a light switch, photons stream from the bulb to your retina. From your perspective, this takes a tiny fraction of a second. But from the photon's perspective, the emission from the bulb and absorption in your eye happen simultaneously. There is no journey, no travel time, no duration. The photon exists in an eternal now that spans its entire path through space. This timeless nature of light has been confirmed by countless experiments. In particle accelerators around the world, physicists routinely create high-energy photons that travel for miles through complex detector systems. From our perspective, these photons take measurable amounts of time to complete their journeys. But according to the mathematics of special relativity, from the photon's own reference frame, the entire journey from creation to detection happens in zero time. The same principle applies to the light reaching us from the most distant corners of the observable universe. The cosmic microwave background radiation, the afterglow of the Big Bang, has been traveling through space for 13.8 billion years from our perspective. This ancient light carries information about the universe when it was only 380,000 years old, when atoms first formed and the cosmos became transparent to light. But from the perspective of those photons themselves, their emission in the early universe and their detection by our satellites and telescopes today happen in the same instant. 13.8 billion years of cosmic history collapse into a single, timeless moment from light's point of view. The entire observable universe, stretching across billions of light years, exists as a simultaneous reality in the reference frame of light. But the connection between light and time runs even deeper. In Einstein's relativity, space and time are not separate entities, but are woven together into a single fabric called space-time. And it's the speed of light that defines the structure of this fabric. The speed of light, that fundamental constant of 299,792,458 meters per second, isn't just the speed at which light travels. It's the speed at which causality itself propagates through the universe. This speed limit determines what can affect what, when effects can follow causes, and how events in one location can influence events in another. Light doesn't just happen to travel at this cosmic speed limit. Light defines it. The speed of light is more accurately understood as the speed of space-time itself, the rate at which reality unfolds. When we measure distances in space, we're really measuring them in units of time multiplied by the speed of light. A light year isn't just a convenient unit for astronomical distances. It reveals the fundamental connection between space and time. Every measurement of space is secretly a measurement of time, and every measurement of time is anchored in the behavior of light. This interconnection goes deeper than most people realize. The meter, our fundamental unit of distance, is officially defined as the distance light travels in vacuum during exactly 1,299,792,458 of a second. We've literally defined space in terms of light and time. But the second itself is defined by the vibrations of cesium atoms, which are electromagnetic oscillations, waves of light at a specific frequency of 9,192,631,770 cycles per second. So we define space using light and time using light and space, creating a circular definition that reveals something profound. Space, time, and light are not separate things that interact. They are different aspects of a single, unified reality. They are three faces of the same cosmic coin. The precision of atomic clocks, which form the backbone of our global positioning system and internet infrastructure, depends entirely on the electromagnetic properties of atoms. These clocks measure time by counting the oscillations of electromagnetic radiation as electrons transition between energy levels in atoms. The most accurate atomic clocks can measure time to within 1 second in 30 billion years, and they do so by counting cycles of light. Even more remarkably, light carries information about time itself. When we look at distant objects in the universe, we're not seeing them as they are now, but as they were when their light began its journey toward us. Light is a messenger from the past, carrying the history of the universe across space and time. This makes light not just a clock, but a time machine. Every time you look at anything, you're seeing into the past. The words on this screen reach your eyes as photons that left the screen just nanoseconds ago. The moon you see is 1.3 seconds in the past. The sun is 8 minutes and 20 seconds in the past. The nearest star, Proxima Centauri, is 4.2 years in the past. And the most distant galaxies we can observe existed when the universe was just a cosmic infant, less than 1 billion years old. The light from these distant galaxies has been traveling through expanding space for billions of years. As it journeys toward us, the expansion of the universe stretches the wavelengths of this light, shifting it toward the red end of the spectrum. This cosmological redshift tells us not just how far away these galaxies are, but how long ago their light began its journey. By measuring the redshift of distant objects, we can map the history of the universe itself. The Hubble Space Telescope and now the James Webb Space Telescope are essentially time machines, peering deeper and deeper into the past with every more distant object they observe. When we look at a galaxy 10 billion light years away, we're seeing it as it was 10 billion years ago, when the universe was less than 4 billion years old. The light from that galaxy has been traveling through space for more than twice as long as Earth has existed. Some of the most distant objects we can observe are quasars, supermassive black holes actively feeding on surrounding matter and shining with the brightness of 1 trillion suns. The light from the most distant quasars has been traveling for over 13 billion years, showing us these cosmic monsters as they existed when the universe was less than 1 billion years old. Yet even in normal physics, light already challenges our intuitive ideas about time. If light is timeless from its own perspective, if it experiences no duration in its journey across the cosmos, then what does this tell us about the nature of time itself? Maybe time isn't as fundamental as we think. Maybe time is something that emerges only for objects with mass, objects that can't travel at the speed of light. This suggests a universe where timeless light connects moments across space, where information and causality flow not through time, but through a more fundamental structure that transcends our everyday experience of temporal flow. Light might not be bound by time, because light might be the thing that creates our perception of time in the first place. Every photon carries with it a piece of cosmic history, a fragment of the eternal now that connects all moments and all places. When light from different sources reaches your eyes simultaneously, photons that began their journeys at vastly different times in cosmic history converge in the same instant of your perception. Your visual experience is a collision of multiple timelines, multiple histories, all brought together by the timeless nature of light itself. Consider what happens when you look up at the night sky. The photons entering your eye at any given moment left their sources at completely different times. Light from the moon left 1.3 seconds ago. Light from Jupiter left between 33 and 54 minutes ago, depending on where Earth and Jupiter are in their orbits. Light from the star Sirius left 8.6 years ago. Light from the Andromeda Galaxy left 2.5 million years ago. All of these photons, carrying information from vastly different epochs, converge on your retina in the same instant. Your brain processes them as a single unified image of the night sky. But what you're actually seeing is a complex layering of different moments in cosmic history, all made present by the timeless journey of light. The deeper we look into the physics of light, the more it appears that light doesn't travel through time so much as it stitches time together. It creates the connections between past and present, between cause and effect, between one location and another. In a very real sense, light might be the scaffolding upon which our entire experience of temporal reality is built. This becomes even more fascinating when we consider quantum mechanics. At the quantum level, light exhibits properties that challenge our classical understanding of both space and time. Photons can exist in superposition, seemingly in multiple places at once until they're observed. They can be entangled with other photons, creating instantaneous correlations across arbitrary distances that appear to transcend the normal limitations of space-time. These quantum properties of light suggest that even our relativistic understanding might be incomplete. If light can exist in superposition, occupying multiple paths simultaneously until measured, then what does this mean for its relationship to time? Perhaps the timeless nature of light in relativity is just the beginning of a deeper truth about the fundamental unreality of time itself. But what does it mean to say the universe might be timeless? To understand this revolutionary possibility, we need to venture beyond the familiar territory of relativity into even stranger theoretical landscapes where time itself might not exist at all. The idea that time might not be fundamental, that it might be an illusion or an emergent property rather than a basic feature of reality, is perhaps the most radical concept in modern physics. It challenges everything we think we know about existence, causality, and the very nature of reality itself. But this isn't just philosophical speculation. Some of the most rigorous theories in physics are pointing toward a universe that is fundamentally timeless. To understand what a timeless universe means, we need to start with a thought experiment that will fundamentally challenge your perception of reality. Imagine you could step outside of time entirely, becoming a cosmic observer who can see all of space-time laid out like a vast landscape. From this impossible vantage point, past, present, and future would all be equally real, equally visible, spread out before you like a four-dimensional map. This is the essence of what physicists call the block universe theory, also known as eternalism. In this view, time doesn't flow. Nothing moves from past to future. Instead, all moments that ever were, are, or will be exist simultaneously in a static, eternal structure. Your birth, your death, and every moment of your life exist as permanent features of this timeless reality, like cities on an infinite map. The block universe isn't just a philosophical curiosity. It emerges naturally from Einstein's special and general relativity. When Einstein showed that simultaneity is relative, that events which appear simultaneous to one observer can occur at different times for another observer moving at high speed, he revealed something profound about the nature of time itself. If there's no universal now, no moment that counts as the present for the entire universe, then perhaps the entire notion of temporal flow is an illusion. Consider two observers, Alice and Bob, moving at high speed relative to each other. According to special relativity, events that Alice considers simultaneous will not be simultaneous from Bob's perspective. An event that Alice sees as happening now might be in Bob's past or future. This relativity of simultaneity suggests that there's no objective division between past, present, and future. All moments are equally real from the perspective of space-time itself. This leads to a startling conclusion. If all moments are equally real, if past and future have the same ontological status as the present, then time doesn't flow from one moment to the next. Instead, we exist as extended four-dimensional objects stretched across space-time, with our earlier and later moments being just as real as our current moment. You don't move through time, you are distributed across time. The implications are staggering. In a block universe, nothing ever really happens. Everything that we perceive as change, as motion, as the passage of time, is simply the pattern of differences between different regions of the static space-time block. Motion isn't objects moving through space over time. It's the shape that extended four-dimensional objects take as they snake through space-time. But the block universe is just one way that modern physics suggests time might be illusory. Even more radical possibilities emerge when we venture into quantum gravity, the attempt to unify Einstein's general relativity with quantum mechanics. Here, in the deepest levels of physical theory, time doesn't just flow differently or have a different structure. Time disappears entirely. The Wheeler-DeWitt equation, often called the equation for the wave function of the universe itself, contains no time variable at all. This equation attempts to describe the quantum state of the entire universe, and in doing so, it reveals something shocking. At the most fundamental level, the universe might be completely timeless. The Wheeler-DeWitt equation describes a static quantum state that encompasses all possible configurations of matter and energy throughout what we think of as space and time. This doesn't mean the universe is frozen or unchanging in the way we might imagine. Instead, it suggests that change itself is an emergent phenomenon, something that appears only when we focus on particular aspects of the universal quantum state. Time, according to this view, is like temperature. Temperature doesn't exist for individual atoms. It only emerges when we consider the statistical behavior of large collections of atoms. Similarly, time might only emerge when we consider particular subsystems of the universe and their relationships to each other. This leads us to one of the most beautiful and strange ideas in quantum gravity, the Page-Wouters mechanism. Proposed by Don Page and William Wouters in 1983, this mechanism shows how time can emerge from timeless quantum correlations. In their approach, time isn't a fundamental dimension of reality. Instead, It's a measure of correlation between different parts of a quantum system. Imagine the universe as a vast quantum system in a timeless superposition of all possible states. Within this timeless whole, different subsystems can become correlated with each other in ways that create the appearance of temporal evolution. One subsystem acts as a clock for another, and the correlation between their states creates the experience of time passing. But this temporal experience emerges from the underlying timeless quantum correlations. This is profoundly different from our everyday understanding of time. In the Page Wouters picture, time doesn't exist as a universal background against which events unfold. Instead, time is relational, emerging from the entanglement patterns between different parts of the universe. Different observers, entangled with different aspects of the universal quantum state, can experience different temporal flows or even different temporal directions. The implications for cosmology are revolutionary. If the universe is fundamentally timeless, then the Big Bang isn't an event that happened 13.8 billion years ago. Instead, it's a boundary condition of the timeless quantum state that describes all of space-time. The expansion of the universe, the formation of galaxies and stars, the evolution of life on Earth, all of these apparent temporal processes are different aspects of the same eternal, unchanging quantum reality. This view finds support in some approaches to quantum cosmology. In models based on the Hartley-Hawking no-boundary proposal, the universe doesn't begin at a specific moment in time. Instead, time itself emerges gradually from a more fundamental, timeless geometry. Near what we call the Big Bang, the distinction between time and space breaks down entirely. Time becomes imaginary in the mathematical sense, and the universe exists in a state that transcends our normal concepts of temporal evolution. Loop quantum gravity, another approach to quantum gravity, also suggests that time might be emergent rather than fundamental. In loop quantum gravity, space-time is built up from discrete quantum loops at the Planck scale, tiny loops of gravitational field that exist at the smallest possible scales of length and time. But these fundamental loops don't exist in time. They constitute the fabric from which space-time itself is woven. At the Planck scale, roughly 10 to the negative 35 meters and 10 to the negative 43 seconds, our normal concepts of space and time break down completely. The quantum fluctuations of space-time itself become so violent that the very notion of a smooth, continuous space-time becomes meaningless. In this quantum foam, as it's sometimes called, there may be no meaningful distinction between past and future, no clear causal order, no definitive temporal flow. Yet somehow, from this timeless quantum chaos, the smooth space-time of our everyday experience emerges. Time, as we know it, might be a large-scale approximation, a useful description that works only when we average over the wild quantum fluctuations at the Planck scale. Just as a smooth liquid like water emerges from the chaotic motion of countless individual molecules, smooth time might emerge from the chaotic quantum dance of space-time at the smallest scales. This emergence of time from timelessness isn't just a theoretical curiosity. It may be directly related to some of the deepest puzzles in physics. The problem of time in quantum gravity has puzzled physicists for decades. General relativity describes a universe where time is dynamical, curved and stretched by matter and energy. But quantum mechanics seems to require a fixed background of time against which quantum evolution can unfold. Reconciling these two pictures has proven extraordinarily difficult. The timeless approach to quantum gravity sidesteps this problem by eliminating time from the fundamental description entirely. If the universe is fundamentally timeless, then there's no conflict between the dynamical time of relativity and the background time of quantum mechanics. Both are emergent approximations that work well in their respective domains, but neither captures the deepest level of reality. This timeless view also connects to some of the strangest phenomena in quantum mechanics. Quantum entanglement, the spooky action at a distance that so troubled Einstein, becomes less mysterious in a timeless universe. If all moments are equally real, if the universe is fundamentally a single, eternal quantum state, then correlations between distant parts of this state don't need to propagate through space and time. They're built into the eternal structure of reality itself. Recent experiments with quantum entanglement have revealed correlations that seem to transcend space and time in precisely this way. When two particles are entangled, measuring one instantly affects the other, regardless of the distance between them. This instantaneous correlation appears to violate the speed of light limit, but it doesn't violate causality because no information can be transmitted through the entanglement. Instead, the correlation seems to exist outside of normal space-time, as if it's built into the fundamental structure of reality. In a timeless universe, such correlations make perfect sense. They're not mysterious action at a distance. They're simply features of the eternal quantum state that describes all of reality. The appearance of instantaneous correlation arises only when we try to describe this timeless reality using the language of temporal evolution and spatial separation. But perhaps the most profound implication of a timeless universe concerns the nature of existence itself. If time is an illusion, if all moments are equally real, then what does it mean to exist? Are you the momentary pattern of thoughts and sensations you experience right now? Or are you the entire four-dimensional structure that extends from your birth to your death? In a timeless universe, the answer might be both and neither. Your existence might be like a melody. A melody isn't contained in any single note. It exists as a pattern that extends across time. But in a timeless universe, this temporal pattern would be laid out eternally, like the grooves on a record that contains the entire song simultaneously. Your consciousness, your memories, your experiences would all be permanent features of this timeless reality. This view offers a strange kind of comfort. In a timeless universe, nothing is ever truly lost. Every moment of joy, every experience of beauty, every act of love exists eternally as part of the unchanging structure of reality. Death becomes not an ending, but simply the boundary of your four-dimensional existence. No more tragic than the way a melody has a beginning and an end. Yet this comfort comes with a profound challenge to our sense of agency and purpose. If everything that will happen has already happened, if your entire life is laid out eternally in the block of space-time, then what room is there for choice, for growth, for the possibility that things could be different? These questions lead us to an even deeper mystery. If the universe is timeless, if time doesn't flow, then how does anything move? How does light travel from one place to another? How do we perceive change and motion in a reality that is fundamentally static and eternal? To answer these questions, we need to explore what motion and travel might mean in a universe where time doesn't exist. If the universe is truly timeless, if time is nothing more than an emergent illusion arising from deeper timeless structures, then we face a profound paradox. How can light move? How can anything travel from one place to another if there is no time through which to travel? This question strikes at the heart of our understanding of motion, causality, and the very nature of physical reality. To understand how light can exist in a timeless universe, we need to fundamentally reimagine what we mean by motion itself. In our everyday experience, motion is the change of position over time. A car moves because it's in one location at one moment and a different location at a later moment. Light moves because photons leave a source at one time and arrive at a detector at a later time. But if time doesn't exist, if all moments are equally real and simultaneous, then this conventional understanding of motion breaks down completely. In a timeless universe, motion doesn't happen, it simply is. Instead of objects moving through space over time, we have extended structures that span across what we perceive as space and time. Think of it like this. Imagine a long, straight road stretching across a landscape. From high above, you can see the entire road simultaneously, from beginning to end. The road doesn't move, it simply exists as a complete structure spanning across space. Now imagine that same road, but spanning across space-time instead of just space. What we perceive as a photon moving from point A to point B would actually be a four-dimensional structure, a kind of space-time road that connects the emission event to the absorption event. The photon doesn't travel along this road, it is the road. The entire trajectory exists eternally as a permanent feature of the space-time landscape. This isn't just philosophical speculation. It emerges naturally from the mathematics of relativity. In Einstein's space-time, the path of a photon is called a light-like geodesic, a curve through four-dimensional space-time that represents the photon's entire history from emission to absorption. But in the block universe view, this geodesic isn't a path that the photon follows. It's the complete description of the photon's existence. The photon is the geodesic. Consider what this means for our understanding of light's journey across the cosmos. When we observe light from a distant star, we typically think of photons that left the star years ago and traveled through space to reach our eyes. But in a timeless universe, there is no journey. Instead, there's a four-dimensional light structure that connects the emission event on the star's surface to the absorption event in your retina. This structure exists eternally, spanning across space and time simultaneously. The entire concept of travel time becomes meaningless in this picture. We can't ask how long it took the photon to make the journey because there is no temporal journey. The emission and absorption events are both permanent features of the timeless space-time block, connected by the eternal structure we call the photon's world line. This perspective is supported by some of the strangest results in quantum mechanics. Richard Feynman's sum over history's approach to quantum mechanics describes particles, including photons, as taking all possible paths between 2 points simultaneously. In the traditional interpretation, we imagine the photons somehow exploring every possible route and then interfering with itself to produce the observed result. But in a timeless universe, this becomes much more natural. The photon doesn't explore different paths sequentially. All possible paths exist simultaneously as features of the eternal quantum state. In Feynman's approach, the probability amplitude for a photon to travel from point A to point B is calculated by summing over all possible space-time paths connecting these points. Each path contributes to the final amplitude, and the interference between these contributions determines the observed behavior. But if space-time is fundamentally timeless, then all these paths exist simultaneously. The photon doesn't choose a path, it is all the paths. This leads to a remarkable insight. In a timeless universe, light doesn't move through space, it defines the structure of space. The network of all possible light paths creates the geometric framework within which all other physics takes place. Space and time aren't a stage upon which light moves, they're the pattern created by light's eternal existence. This becomes even more profound when we consider the role of light in defining causality. In relativity, the speed of light defines the light cone, the region of space-time that can influence or be influenced by a given event. Events within the light cone are causally connected, while events outside the light cone are causally disconnected. But in a timeless universe, these causal connections aren't established by signals traveling through time. They're built into the eternal structure of space-time itself. The light cone isn't created by light signals propagating outward from an event. It's a permanent geometric feature of space-time that defines which events can be connected by light like geodesics. Causality doesn't flow through time, It's encoded in the timeless geometry of space-time. What we perceive as cause and effect is really the pattern of correlations built into the eternal structure of reality. This timeless view of light also transforms our understanding of electromagnetic phenomena. In traditional physics, electromagnetic waves propagate through space and time, carrying energy and information from one location to another. But in a timeless universe, electromagnetic fields don't propagate. They simply exist as four-dimensional structures in space-time. Maxwell's equations, which describe the behavior of electromagnetic fields, can be reformulated in ways that make no reference to time evolution. Instead of fields changing over time, we have static field configurations in four-dimensional space-time. What we perceive as a wave moving through space is really a four-dimensional wave structure that exists eternally, like a frozen wave on an infinite ocean. This static view of electromagnetic fields connects to some of the deepest principles in physics. The principle of least action, one of the most fundamental principles in all of physics, describes how physical systems evolve by finding the path that minimizes a quantity called the action. But in a timeless universe, this principle takes on a different meaning. Instead of systems evolving to minimize action over time, the entire space-time configuration exists as the one that minimizes action over all of space and time simultaneously. Light follows geodesics in space-time, not because it chooses the shortest path, but because the entire space-time configuration, including all light paths, exists as the static solution that minimizes the total action. Light doesn't find its path. The path is a necessary feature of the optimal space-time configuration. This perspective also illuminates the relationship between light and gravity. In general relativity, massive objects curve space-time, and light follows the resulting geodesics through this curved geometry. We typically think of this as light being deflected by gravitational fields as it travels. But in a timeless universe, the curvature of space-time and the paths of light are both features of the same eternal geometric structure. A black hole doesn't trap light by preventing it from escaping. Instead, the geometry near a black hole is such that all light-like geodesics curve back inward. The entire space-time geometry, including the black hole and all the light paths around it, exists as a single, eternal configuration. Light doesn't fall into the black hole. The inward curving light paths are part of the geometric definition of what a black hole is. This leads to fascinating insights about the event horizon, the boundary beyond which light cannot escape from a black hole. In the traditional view, the event horizon is defined by the last light signals that can escape to infinity. But in a timeless universe, the event horizon is simply a geometric feature of the eternal space-time structure, the boundary between inward curving and outward extending light paths. Even more remarkably, this timeless view helps resolve some of the deepest paradoxes in black hole physics. The information paradox, which asks what happens to information that falls into a black hole, becomes less mysterious when we abandon the idea of temporal evolution. Information doesn't fall into the black hole and then get destroyed or somehow escape. Instead, the information content of the entire space-time configuration, including the black hole and everything around it, is conserved as a feature of the eternal geometric structure. The timeless perspective also transforms our understanding of quantum aspects of light. In quantum field theory, virtual photons mediate electromagnetic interactions between charged particles. We typically think of these virtual photons as being exchanged between particles, traveling from one to the other to carry the electromagnetic force. But in a timeless universe, virtual photons don't travel. Instead, they exist as permanent features of the quantum field configuration that connects interacting particles. When two electrons repel each other electromagnetically, we usually imagine virtual photons being exchanged between them, carrying momentum and energy to create the repulsive force. But in a timeless quantum field theory, the interaction is mediated by the quantum field configuration that exists eternally throughout space-time. The virtual photons are aspects of this field configuration, not particles traveling through time. This connects to the holographic principle, one of the most profound insights to emerge from string theory and quantum gravity. The holographic principle suggests that all the information contained in a volume of space can be encoded on the boundary of that volume. In a timeless universe, this principle takes on new meaning. The information about light and electromagnetic fields throughout a region of space-time might be entirely encoded in the boundary conditions of that region. In this holographic view, light doesn't carry information from one place to another through the bulk of space-time. Instead, all information exists simultaneously on the boundaries of space-time regions, and what we perceive as light propagation is really the correlation structure encoded in these boundary conditions. Light doesn't move through space. It is the pattern of correlations that defines how different regions of space are connected. This holographic perspective is supported by research in ADS-CFT correspondence, one of the most successful examples of the holographic principle. In ADS-CFT, a gravitational theory in the bulk of space-time is equivalent to a conformal field theory on the boundary. Light paths in the bulk correspond to correlation functions in the boundary theory, but in the boundary theory, there is no notion of light traveling through the bulk. Instead, the boundary theory is a timeless quantum system where all correlations exist simultaneously. The implications extend to our understanding of observation and measurement. When we detect a photon, we typically think of it as the end of the photon's journey through space and time. But in a timeless universe, detection is not the end of a temporal process. It's a correlation between the detector and the eternal light structure. The detector and the light source are connected by the permanent geometric relationship encoded in space-time. This transforms the entire concept of experimental physics. When we measure the properties of light, we're not observing something that traveled through time to reach our detector. Instead, we're accessing information about the eternal correlations built into the structure of space-time itself. Every measurement reveals something about the timeless pattern that connects all events in the universe. The speed of light, that fundamental constant that appears to govern how fast light travels, takes on new meaning in a timeless universe. It's not really a speed in the usual sense, because speed requires time and distance, and in a fundamental sense, neither time nor space exists independently. Instead, the speed of light is a geometric constant that characterizes the relationship between space-like and time-like directions in space-time. It defines the fundamental structure of the space-time metric. From this perspective, light doesn't travel at the speed of light. Light defines what we mean by the speed of light. The speed of light is the conversion factor between space and time coordinates, the fundamental constant that allows us to treat space and time as aspects of a unified four-dimensional geometry. Light doesn't move through this geometry. It is the geometric structure. This brings us to perhaps the most profound question of all. If light doesn't move, if it exists as eternal structure spanning space-time, then how do we perceive motion? How do we experience the arrival of light signals? The passage of electromagnetic waves? The flow of photons from source to detector? The answer lies in understanding how consciousness and perception work in a timeless universe, and how our experience of temporal flow emerges from the eternal structure of reality. If light doesn't actually travel through time, if it exists as an eternal structure spanning space-time, then how can it connect causes to their effects? How can the flash of a lightning bolt cause the thunder we hear, or the flip of a light switch cause photons to stream into our eyes? This question probes one of the deepest mysteries in physics, the relationship between causality and time, and reveals that our understanding of cause and effect may be as illusory as our perception of temporal flow. In our everyday experience, causality seems inseparable from time. Causes precede effects. Events unfold in sequence. One thing leads to another through the flowing river of time. But in a timeless universe, this temporal ordering of cause and effect becomes meaningless. There is no before and after, no sequence of events, no flowing from one moment to the next. Yet somehow, the universe still exhibits the patterns we call causal relationships. To understand causality without time, we need to fundamentally reimagine what we mean by cause and effect. Instead of one event causing another event to happen later, we need to think of causality as a pattern of relationships built into the eternal structure of space-time itself. Causality doesn't flow through time. It's encoded in the geometric connections between events in the timeless block of space-time. The key insight comes from understanding that light defines the causal structure of space-time. In relativity, the light cone originating from any event divides space-time into 3 regions. Events in the future light cone can be influenced by the original event. Events in the past light cone can influence the original event, and events outside the light cone are causally disconnected from the original event. This structure doesn't depend on the flow of time. It's a geometric feature of space-time itself. Think of it this way. Imagine space-time as a vast crystalline structure, with each point representing an event. The causal relationships between events are like the bonds between atoms in the crystal, permanent connections that exist as features of the structure itself. Light doesn't create these connections by traveling between events. Light is the geometric pattern that defines which connections are possible. When we say that a lightning flash causes thunder, we're not describing a temporal sequence where one event makes another event happen later. Instead, we're identifying a geometric relationship in space-time where the lightning event and the thunder event are connected by a specific pattern of light, like geodesics. The lightning and thunder events exist simultaneously in the eternal block of space-time, connected by the permanent causal structure encoded in the geometry. This geometric understanding of causality is supported by the mathematics of general relativity. Einstein's field equations don't describe how space-time evolves over time. They describe the static geometric relationship between matter and the curvature of space-time. The entire space-time manifold, including all events and all causal relationships, exists as a single 4-dimensional solution to the field equations. In this view, causality is preserved not because effects follow causes in time, but because the geometric structure of space-time ensures that causal relationships are consistent throughout the entire 4-dimensional block. Events are ordered not by temporal sequence, but by their geometric separation in space-time. Light, like geodesics, define which events can be causally connected, and this geometric ordering is built into the eternal structure of reality. Consider what happens when you flip a light switch. In the traditional view, your action causes electric current to flow, which causes the bulb to emit photons, which travel through space and time to reach your eyes, causing you to see the light. But in a timeless universe, the switch flip, the current flow, the photon emission, and your visual experience all exist simultaneously as correlated features of the eternal space-time configuration. The causal relationship between these events isn't established by signals traveling through time. It's encoded in the geometric connections that exist timelessly throughout space-time. Your decision to flip the switch, the resulting photon emission, and your visual experience are all part of a single, self-consistent pattern that exists eternally in the block universe. This might seem to eliminate free will and reduce human agency to an illusion, but the reality is more subtle. Even in a timeless universe, your decisions and actions are real features of the space-time configuration. The pattern of your thoughts, choices, and behaviors contributes to determining what the eternal configuration looks like. You don't create effects that follow your causes in time, but but your agency helps determine the overall pattern of correlations that exists timelessly throughout space-time. The relationship between causality and information becomes particularly important in this timeless view. In traditional physics, information propagates from cause to effect through light signals and other causal influences. But in a timeless universe, information doesn't propagate. It's distributed throughout the geometric structure of space-time according to the causal ordering defined by light cones. When you send a text message to a friend, you typically think of information traveling from your phone through electromagnetic waves to their phone. But in a timeless universe, the information doesn't travel. Instead, the correlation between your typing the message and your friend reading it is a permanent feature of the space-time geometry. The electromagnetic signals that seem to carry the information are really just part of the geometric pattern that connects the correlated events. This geometric view of information transfer helps resolve some puzzles about the speed of light. We often ask why light travels at exactly 299,792,458 meters per second, as if this were an arbitrary speed limit imposed on photons. But in a timeless universe, this isn't really a speed at all. It's a geometric ratio that defines the relationship between space-like and time-like directions in spacetime. Light doesn't travel at this speed. This ratio defines what we mean by light-like geodesics in spacetime. The speed of light is the fundamental constant that determines the causal structure of spacetime itself. It defines which events can be causally connected and which cannot, establishing the geometric framework within which all causal relationships exist. This framework explains why nothing can travel faster than light. It's not that light sets a speed limit that other things must obey. It's that light-like geodesics define the boundary of causal connection in spacetime. Events separated by space-like intervals cannot be causally connected, not because signals can't travel fast enough between them, but because the geometric structure of spacetime doesn't include causal connections across space-like separations. The implications extend to quantum mechanics and the strange phenomenon of quantum entanglement. When two particles are entangled, measuring one instantly affects the other, regardless of the distance between them. This appears to violate the speed of light limit and create causal connections outside the light cone. But in a timeless universe, quantum entanglement becomes much less mysterious. Entangled particles don't need to send signals to each other because their correlation is built into the eternal quantum state that describes all of spacetime. The instant correlation between distant entangled particles isn't a causal influence propagating faster than light. It's a geometric feature of the timeless quantum configuration. The particles were never separate in the first place. They're part of a single quantum system distributed across spacetime. This connects to the Einstein-Podolsky-Rosen paradox, which challenged the completeness of quantum mechanics by showing that entangled particles seem to exhibit spooky action at a distance. Einstein believed that quantum mechanics must be incomplete because it seemed to allow instantaneous influences between distant objects. But in a timeless universe, there are no instantaneous influences because there is no time across which influences could propagate. The correlations between entangled particles are like the correlations between different parts of a single object. When you rotate a rigid object, all parts of the object rotate simultaneously, not because one part sends signals to the others, but because they're all part of the same unified structure. Similarly, entangled particles are correlated not because they influence each other across space and time, but because they're part of the same unified quantum structure in space-time. This timeless view of quantum mechanics connects to the many worlds interpretation and the idea that all possible quantum outcomes exist simultaneously. In a timeless quantum universe, all possible histories and all possible measurement outcomes exist as equally real features of the eternal quantum state. What we perceive as the collapse of the wave function and the selection of a particular outcome is really just our particular perspective on the timeless quantum configuration. The measurement process doesn't cause the wave function to collapse, creating a definite outcome from quantum superposition. Instead, measurement is the correlation between the quantum system and the measuring apparatus, both of which exist as features of the eternal quantum state. Different measurement outcomes don't happen at different times. They exist simultaneously as different branches of the universal quantum configuration. This brings us to one of the most profound aspects of causality in a timeless universe: the relationship between consciousness and causal order. Our perception of cause and effect seems to depend crucially on our consciousness, our ability to remember the past and anticipate the future. But if time doesn't flow, if past and future are equally real, then how does consciousness create the experience of causal order? The answer may lie in the thermodynamic arrow of time and the increase of entropy. Even in a timeless universe, there's an asymmetry built into the structure of space-time. The configuration of matter and energy that we call the past has lower entropy than the configuration we call the future. This entropy gradient creates a preferred direction through space-time, even though space-time itself is timeless. Consciousness might be fundamentally connected to this entropy gradient. Our brains are complex systems that process information by creating correlations between different neural states. These correlations follow the thermodynamic arrow of time, creating memories of lower entropy states and forming expectations about higher entropy states. This gives us the subjective experience of moving from past to future, even though we're really just accessing different parts of the eternal space-time configuration. In this view, causality and temporal flow are both emergent properties of consciousness interacting with the entropy structure of space-time. We perceive causes preceding effects not because this temporal ordering is fundamental, but because our brains are structured to form memories and correlations that align with the thermodynamic arrow of time. The speed of light plays a crucial role in this emergence of causal order. Because information can only be correlated across time-like or light-like separated events, the speed of light defines the rate at which conscious systems can form new correlations and update their internal models of reality. This creates the subjective experience of time passing at a particular rate, even though time doesn't actually flow. When you see a lightning flash and then hear thunder, your brain correlates these sensory inputs according to their arrival time and the known speed of light and sound. This creates the subjective experience of temporal sequence and causal connection. But the lightning and thunder events themselves exist simultaneously in space-time, connected by the geometric structure that defines their causal relationship. This understanding of causality without time has profound implications for physics beyond relativity and quantum mechanics. In thermodynamics, the second law states that entropy tends to increase over time. But in a timeless universe, this isn't a temporal evolution, it's a geometric feature of the space-time configuration. The entropy gradient points in a particular direction through space-time, defining what we perceive as the arrow of time. Heat doesn't flow from hot objects to cold objects because of temporal evolution. It flows because the geometric structure of space-time includes an entropy gradient that defines this preferred direction. The statistical mechanics of countless particles doesn't evolve toward higher entropy states. Instead, the eternal configuration of all particles throughout space-time includes the pattern we interpret as entropy increase. Even the expansion of the universe takes on new meaning in this timeless view. The universe doesn't expand over time, growing larger as time passes. Instead, the four-dimensional space-time configuration includes a variation in scale that we interpret as expansion when we follow time like curves through space-time. The Big Bang isn't an event that happened in the past. It's a boundary condition of the eternal space-time geometry. This connects causality to the deepest questions about the origin and nature of physical laws themselves. In traditional physics, we ask why the universe obeys particular laws, and how these laws give rise to the phenomena we observe. But in a timeless universe, physical laws aren't rules that govern temporal evolution. They're geometric principles that determine what kinds of space-time configurations can exist. The laws of physics become constraints on the possible geometric structures of space-time, rather than dynamical rules that determine how things change over time. Causality isn't about one event making another event happen. It's about which geometric relationships are consistent with the fundamental constraints that define possible space-time configurations. This geometric understanding of physical laws and causality points toward an even deeper unity between space, time, matter, and information. In a truly timeless universe, these aren't separate ingredients that interact according to causal rules. They're different aspects of a single geometric structure that exists eternally and contains all of reality within its four-dimensional embrace. But if causality doesn't require time, if cause and effect are geometric relationships rather than temporal sequences, then what happens when we probe the deepest levels of reality, where even space and time break down? To answer this question, we need to venture into the realm of quantum gravity, where time doesn't just flow differently or have a different structure, but where time disappears entirely from the fundamental description of reality. At the deepest level of physical reality, where quantum mechanics meets general relativity, something extraordinary happens to time. It doesn't just slow down or speed up or become relative. It vanishes entirely. In the mathematical frameworks that attempt to describe quantum gravity, time ceases to be a fundamental feature of reality and becomes something that emerges only as an approximation, like the way the smooth surface of a lake emerges from countless individual water molecules dancing in chaotic motion. This disappearance of time at the quantum gravitational level represents perhaps the most radical departure from our everyday understanding of reality that physics has ever proposed. It's not just that time behaves strangely at extreme scales, it's that time, as a fundamental concept, may not exist at all in the deepest description of nature. The journey to this startling conclusion begins with one of the most important equations in theoretical physics, the Wheeler-DeWitt equation. Named after John Wheeler and Bryce DeWitt, this equation attempts to describe the quantum mechanical wave function of the entire universe. But when you write down this equation, something shocking becomes immediately apparent. There is no time variable anywhere to be found. In ordinary quantum mechanics, the Schrödinger equation describes how quantum wave functions evolve over time. Time appears explicitly in the equation as the parameter that drives quantum evolution. But the Wheeler-DeWitt equation, which should describe the quantum state of all of space-time, contains no time parameter at all. The universe, according to this equation, exists in a timeless quantum superposition of all possible spatial configurations. This absence of time in the Wheeler-DeWitt equation isn't an oversight or a mathematical convenience. It's a direct consequence of trying to apply quantum mechanics to gravity and space-time itself. In general relativity, time is not a fixed background against which events unfold. Time is part of the dynamical fabric of space-time, curved and stretched by matter and energy. But quantum mechanics seems to require a fixed time parameter to describe how quantum states evolve. When you try to quantize gravity, to make space-time itself subject to quantum uncertainty, you discover that there's no external time with respect to which the quantum evolution can take place. The universe as a whole has no external clock, no external reference frame. From the perspective of the entire universe, there is simply no time. This leads to what physicists call the problem of time in quantum gravity. If the fundamental equation describing the universe contains no time, then how do we recover the temporal evolution that we observe in everyday physics? How does time emerge from timelessness? How does the dynamic world of change and motion arise from a static quantum equation? One of the most beautiful answers to this puzzle comes from the Page-Wouters mechanism, which shows how time can emerge from timeless quantum correlations. In this approach, time isn't a fundamental parameter, it's a measure of correlation between different parts of the universal quantum state. One subsystem of the universe acts as a clock for another subsystem, and the correlation between their quantum states creates the appearance of temporal evolution. Imagine the universe as a vast quantum symphony where every particle, every field, every degree of freedom is like an instrument playing its part. The Wheeler-DeWitt equation describes the eternal score of this symphony, a timeless mathematical structure that contains all possible correlations between all possible quantum states. But when we focus on particular instruments, particular subsystems, we hear temporal melodies emerging from the timeless harmony. Your brain, for instance, is correlated with the quantum fields around you in ways that create the subjective experience of time passing. The neurons in your brain act like internal clocks, creating correlations with external systems that generate the perception of temporal flow. But this flow isn't fundamental. It's an emergent property of the particular correlations you happen to be embedded in. This emergence of time from timeless quantum correlations connects to some of the deepest insights in quantum gravity. In loop quantum gravity, one of the leading approaches to quantum gravity, space-time itself is quantized at the smallest possible scales. At the Planck length, roughly 10 to the negative 35 meters, and the Planck time, roughly 10 to the negative 43 seconds, space and time break down into discrete quantum units. But these quantum units don't exist in time. They constitute the fundamental fabric from which space-time itself is woven. Think of it like pixels on a computer screen. Individual pixels don't exist within the image displayed on the screen. They are the basic building blocks that create the image. Similarly, the quantum loops of loop quantum gravity don't exist within space-time. They are the fundamental quanta from which space-time itself emerges. At the Planck scale, the very concepts of space and time become meaningless. The quantum fluctuations of space-time become so violent that the geometry of space-time itself fluctuates wildly, creating what physicists call quantum foam. In this foam, there's no smooth space-time, no definite geometry, no clear distinction between space and time directions. There are only quantum fluctuations of geometric relationships that somehow give rise to the smooth space-time of our everyday experience. Loop quantum gravity suggests that these quantum fluctuations are organized into networks of quantum loops, abstract mathematical objects that encode the quantum geometry of space-time. These loops don't exist at particular times or places because time and place are concepts that only emerge when you have many loops interacting together. Individual loops exist in a timeless quantum realm where the usual concepts of physics don't apply. When countless quantum loops interact and correlate with each other, they create the emergent phenomena we call space and time. Space emerges as the pattern of connections between loops. Time emerges as the pattern of correlations that creates the appearance of change and evolution. But at the fundamental level, there are only timeless quantum loops existing in pure mathematical relationships. This connects to another major approach to quantum gravity, string theory, which also suggests that time may be emergent rather than fundamental. In string theory, the basic building blocks of reality are one-dimensional strings vibrating in higher dimensional spaces. But these strings don't vibrate in time. They exist as timeless mathematical objects in abstract configuration spaces. The holographic principle, one of the most important insights to emerge from string theory, suggests that all the information contained in a volume of space can be encoded on the boundary of that volume. In models based on ADS-CFT correspondence, a gravitational theory in the bulk of space-time is equivalent to a conformal field theory on the boundary. But the boundary theory is timeless. it describes quantum correlations without any reference to temporal evolution. In this holographic picture, what we perceive as time in the bulk gravitational theory emerges from the timeless correlation structure of the boundary quantum theory. Time doesn't exist fundamentally. It's a derived concept that appears when we try to describe the timeless boundary theory in terms of bulk physics. Recent developments in quantum gravity have pushed this timeless picture even further. The concept of space-time emergence suggests that not only time, but space itself may be emergent from more fundamental quantum information. In this view, space and time are both approximate concepts that arise when quantum information organizes itself in particular patterns. Think of it like the way a computer simulation can create the appearance of a three-dimensional world from underlying digital information. The simulated world has apparent space and time, apparent objects moving through apparent space over apparent time. But fundamentally, there's only information being processed according to computational rules. Similarly, our universe might be like a vast quantum computation, where space and time are emergent properties of information processing at the quantum level. This information theoretic view of quantum gravity suggests that the fundamental reality is pure quantum information, organized into patterns that create the illusion of space-time. What we think of as particles moving through space and time are really just information processing events in this cosmic quantum computer. Light doesn't travel through space. It is the pattern of information transfer that creates our perception of spatial separation and temporal evolution. The implications for our understanding of light become profound. In traditional physics, light propagates through space-time as electromagnetic waves. But in quantum gravity, space-time itself is emergent from quantum information processing. This means that light, rather than moving through space-time, might be one of the fundamental processes that creates space-time. The quantum field theory of electromagnetism describes light as excitations of the electromagnetic quantum field. But if space-time is emergent, then quantum fields might be more fundamental than the space-time in which we usually think they exist. Light might be a pattern of quantum information processing that helps create the very space and time through which it appears to move. This leads to a remarkable possibility. Instead of light being a phenomenon that occurs within space-time, light might be one of the basic building blocks from which space-time is constructed. The network of possible light paths, all the light-like geodesics that connect events in space-time, might form the fundamental scaffold upon which space-time geometry is built. In this view, the speed of light isn't just a fundamental constant that characterizes how light moves through space-time. It's the fundamental ratio that defines the relationship between space-like and time-like directions in the emergent space-time geometry. Light doesn't travel at the speed of light. The speed of light is the geometric constant that determines how the timeless quantum information organizes itself into the apparent space and time of our experience. The causal structure of space-time, the light cone relationships that determine which events can influence which other events, becomes the fundamental organizing principle of quantum information. Instead of information flowing through space-time along causal paths are the patterns along which quantum information organizes itself to create the appearance of space-time. This information theoretic approach to quantum gravity connects to the black hole information paradox in fascinating ways. The paradox arises because black holes appear to destroy information, violating one of the fundamental principles of quantum mechanics. But if space-time itself is emergent from quantum information, then black holes aren't really destroying information. They're reorganizing it in ways that change the emergent space-time geometry. The event horizon of a black hole, which appears to be a boundary in space-time beyond which information cannot escape, might really be a boundary in the organization of quantum information. Information doesn't fall across the event horizon and get destroyed. Instead, the information reorganizes itself in ways that change the apparent geometry of space-time. From the outside, it appears that information can't escape the black hole, but fundamentally, all the information remains encoded in the quantum structure that gives rise to space-time. This connects to the holographic principle applied to black holes. The information content of a black hole is proportional to the area of its event horizon, not its volume. This suggests that the information isn't really inside the black hole, it's encoded on the surface. But in a theory where space-time is emergent from quantum information, this makes perfect sense. The black hole interior and exterior are both emergent descriptions of the same underlying quantum information, organized in ways that create the apparent geometry of curved space-time around a black hole. The emergence of time from timeless quantum gravity also has profound implications for cosmology. The Big Bang, which appears to be the beginning of time in our universe, becomes reinterpreted as the boundary condition of the timeless quantum state that describes all of space-time. The universe doesn't begin at a particular moment and then evolve through time. Instead, the entire history of the universe exists as a timeless solution to the Wheeler-DeWitt equation. The expansion of the universe, the formation of galaxies and stars, the evolution of life, all of these apparently temporal processes are features of the timeless quantum geometry that describes all of space-time. What we perceive as cosmic evolution is really the pattern of correlations built into the eternal quantum state of the universe. This timeless view of cosmology might help resolve some of the deepest puzzles about the universe's beginning. The problem of what came before the Big Bang becomes meaningless if time itself emerges only as an approximation within the timeless quantum state. There is no before, just as there's no outside or underneath. The universe is the complete timeless quantum reality, and temporal concepts like before and after only make sense as emergent approximations within particular regions of this reality. The cosmic microwave background radiation, the afterglow of the Big Bang that still fills the universe today, becomes reinterpreted as a permanent feature of the timeless quantum geometry. This radiation doesn't travel through space and time from the early universe to our detectors today. Instead, it exists as an eternal correlation structure that connects different regions of the emergent space-time. When we observe this cosmic background radiation, we're not seeing light that has traveled for 13.8 billion years. Instead, we're accessing information about the timeless quantum correlations that create the appearance of an expanding universe with a hot, dense past. The radiation carries information not because it traveled through time, but because it represents the correlation structure built into the fundamental quantum geometry of spacetime. But if time emerges only as an approximation, if the fundamental reality is timeless quantum information organizing itself into patterns, then how do we experience the flow of time? How does consciousness create the subjective experience of temporal passage in a universe that is fundamentally timeless? To answer these questions, we need to explore how perception and consciousness work in a reality where time is nothing more than an emergent illusion. If the universe is fundamentally timeless, if all moments exist simultaneously in an eternal block of space-time, then why do we experience time as flowing? Why does it feel like we move from past to future, like moments slip away and new moments arrive? The answer to this profound question lies in understanding how consciousness works in a timeless universe, and how our brains create the magnificent illusion of temporal flow from the static structure of eternal reality. To understand how perception creates time, we need to start with a fundamental insight about consciousness itself. Your brain is not experiencing the present moment. By the time light travels from an object to your eyes, by the time your neurons process the visual information, by the time your conscious mind becomes aware of what you're seeing, the moment you think you're experiencing is already in the past. You are always living in a carefully constructed illusion of the present, assembled by your brain from information that arrived at different times. Consider what happens when you watch a lightning bolt streak across the sky. The light from the bolt reaches your eyes almost instantly, traveling at 299,792,458 meters per second. But the thunder, traveling at only 343 meters per second through air, arrives much later. Your brain automatically correlates these two sensory inputs, creating the unified experience of a lightning storm. But this correlation requires memory, comparison, and temporal processing that happens after both the light and sound have already reached your sensory organs. This simple example reveals something profound about consciousness. Your brain is constantly creating a coherent narrative of experience by correlating information that arrives at different times through different sensory channels. What you experience as the present moment is actually a carefully constructed synthesis of information from multiple past moments, assembled into a unified conscious experience that feels immediate and present. In a timeless universe, this process takes on an entirely different meaning. Your brain isn't creating a representation of a flowing present moment. It's accessing different parts of the eternal space-time structure and synthesizing them into the experience of temporal flow. The lightning and thunder events exist simultaneously in the timeless block of space-time, connected by permanent geometric relationships. Your brain accesses these events through the light and sound that connects them to your sensory organs, creating the subjective experience of sequence and causation. The key insight is that consciousness itself might be fundamentally about creating correlations between different parts of the timeless space-time structure. Your brain is a complex quantum system embedded in the eternal block universe, and your conscious experience emerges from the particular pattern of correlations that your neural networks create with the rest of space-time. Memory plays a crucial role in this process. In our everyday understanding, memory allows us to recall past events and compare them with present experiences. But in a timeless universe, memory serves a different function. Memory is the mechanism by which consciousness accesses different parts of the eternal space-time structure and creates the relationships between them that we experience as temporal sequence. When you remember yesterday's sunset, you're not accessing a record of a past event stored in your brain. Instead, you're accessing the eternal correlation between your current brain state and the sunset event that exists simultaneously with you in the timeless block of space-time. Memory doesn't preserve the past. It creates connections across the eternal structure that allow consciousness to experience the illusion of temporal flow. This understanding of memory connects to some fascinating research in neuroscience. Studies of patients with severe memory disorders reveal that our sense of time depends crucially on our ability to form and access memories. Patients with anterograde amnesia, who cannot form new memories, lose their sense of temporal continuity. They experience each moment as disconnected from all others, unable to construct the narrative flow that creates our normal experience of time. In a timeless universe, these patients haven't lost their ability to move through time. They've lost their ability to create correlations across the eternal space-time structure. Their consciousness becomes trapped in accessing only a small region of space-time, unable to form the broader correlations that create the experience of temporal flow. This suggests that temporal experience is fundamentally about the scope and pattern of correlations that consciousness can create, not about movement through an objective time dimension. The neural basis of time perception provides even more evidence for this correlation-based view of temporal experience. Your brain contains multiple internal clocks, neural circuits that oscillate at different frequencies and create the temporal scaffolding upon which conscious experience is built. These neural oscillations don't track an external flow of time. They create internal correlations that allow your brain to organize information into temporal sequences. Different neural systems operate at different temporal scales. Some neurons fire dozens of times per second, creating rapid correlations that allow you to track fast-moving objects or process speech. Other neural circuits operate on much longer timescales, creating the slower correlations that allow you to plan for the future or reflect on extended experiences. The complex interplay between these different temporal scales creates the rich, multifaceted experience of time that characterizes human consciousness. But in a timeless universe, these neural oscillations aren't tracking the passage of time. They're creating the internal correlation structure that allows consciousness to access different parts of the eternal space-time configuration. The faster oscillations create fine-grained correlations that give you the experience of immediate presence. The slower oscillations create broader correlations that give you the experience of extended duration and temporal depth. This correlational view of consciousness also explains why different conscious systems might experience time differently. A hummingbird, with its rapid neural oscillations and high-frequency information processing, experiences a different temporal flow than a human. Not because time passes differently for the hummingbird, but because the hummingbird's neural system creates different patterns of correlation with the timeless space-time structure. The hummingbird's consciousness accesses the eternal block universe through correlations that operate at much higher frequencies than human correlations. This creates the subjective experience of an expanded present moment, where events that seem instantaneous to humans appear extended and detailed to the hummingbird. The hummingbird doesn't experience faster time, it experiences a different pattern of correlations across the same eternal space-time structure. This principle extends to all conscious systems. Every brain, every nervous system, every information processing structure creates its own unique pattern of correlations with the timeless universe. These correlations determine not just the rate at which time seems to flow, but the very nature of temporal experience for that conscious system. Artificial intelligence systems might eventually develop their own forms of temporal experience based on their computational architectures. A digital consciousness operating on silicon circuits might create correlations that give it the experience of time flowing at computational speeds, with subjective seconds corresponding to millions of computational cycles. Such a system wouldn't experience faster time than humans. It would experience a different correlation structure across the same eternal reality. The role of attention in temporal experience provides another crucial insight into how consciousness creates the illusion of flow. When you focus your attention on something, time seems to slow down. A moment of intense concentration can feel extended and detailed, while periods of routine activity seem to pass quickly. This isn't because time actually flows at different rates, it's because attention modulates the correlation structure that consciousness creates with space-time. Focused attention creates richer, more detailed correlations with particular regions of the eternal space-time block. This creates the subjective experience of temporal expansion, as if the present moment were stretching out to accommodate the increased detail. Unfocused attention creates sparser correlations, leading to the subjective experience of time passing quickly, as large regions of space-time are accessed through minimal correlation structures. This attention-based modulation of temporal experience connects to meditation practices and altered states of consciousness. Experienced meditators report profound changes in their experience of time, including the sense that time has stopped entirely, or that past, present, and future have collapsed into a single eternal moment. In the framework of a timeless universe, these experiences represent changes in the correlation structure that consciousness creates with space-time. Deep meditation might allow consciousness to access the timeless nature of reality more directly, reducing the temporal correlations that normally create the illusion of flow. Instead of experiencing sequential access to different parts of space-time, the meditative consciousness might access a broader, more unified region of the eternal block, creating the subjective experience of timeless presence. Psychedelic experiences, which also profoundly alter temporal perception, might work through similar mechanisms. These substances appear to change the neural correlation structures that create temporal experience, sometimes leading to the sense that time is flowing backwards, that all moments are happening simultaneously, or that the distinction between past, present, and future has dissolved entirely. These aren't hallucinations of impossible temporal phenomena. They're different ways of accessing the same eternal space-time structure. The relationship between consciousness and the thermodynamic arrow of time becomes particularly important in understanding why we experience temporal flow in a particular direction. Even in a timeless universe, there's an asymmetry built into the structure of space-time. The entropy gradient that points from lower entropy configurations to higher entropy configurations creates a preferred direction through the eternal block. Conscious systems, being complex thermodynamic structures that require energy flow to maintain their organization, are intrinsically connected to this entropy gradient. Your brain creates correlations that align with the thermodynamic arrow of time, accessing lower entropy regions of space-time as memories and higher entropy regions as expectations. This creates the subjective experience of moving from past to future, even though you're really just accessing different parts of an eternal structure. The process of forming memories itself increases entropy, creating irreversible correlations between your brain state and external events. This irreversibility, built into the thermodynamic structure of consciousness, creates the asymmetric temporal experience, where the past feels fixed and the future feels open. But this asymmetry isn't fundamental to time itself. It's a feature of how conscious systems interact with the entropy gradient built into the timeless space-time structure. Language and culture play crucial roles in shaping temporal experience as well. Different languages conceptualize time in radically different ways. Some languages have no words for past and future, describing all events in terms of their relationship to the speaker's current state. Other languages require speakers to specify the evidential basis for temporal claims, distinguishing between directly witnessed events, reported events, and inferred events. These linguistic differences aren't just arbitrary cultural variations, they reflect different ways of organizing correlations with the timeless space-time structure. Speakers of different languages don't just talk about time differently, they experience time differently because their neural correlation structures are shaped by the temporal concepts embedded in their language. The philosophy of temporal experience has grappled with these questions for millennia. The ancient philosopher Augustine asked how the present moment could have any duration, since any extended present would have to include past and future parts. In a timeless universe, Augustine's puzzle finds a natural resolution. The present moment doesn't have duration in time, it has extension in the correlation structure that consciousness creates with space-time. The phenomenology of temporal experience, the careful analysis of how time feels from the inside, reveals the constructed nature of temporal flow. The specious present, the immediate temporal field of consciousness, doesn't correspond to any objective present moment. Instead, it corresponds to the scope of correlations that consciousness can create simultaneously across the eternal space-time structure. When you experience the flow of time, you're not experiencing an objective feature of reality flowing around you. You're experiencing the dynamic process by which consciousness creates and updates its correlations with the eternal structure of space-time. The flow isn't in time itself, it's in the correlation structure of consciousness. This has profound implications for the nature of personal identity and the meaning of life in a timeless universe. If you exist as an extended four-dimensional structure across space-time, then every moment of your life, every experience, every thought and emotion exists eternally as part of the permanent furniture of reality. Nothing is ever truly lost, because the timeless structure of space-time preserves all moments equally. Yet the experience of temporal flow, created by the correlation structure of consciousness, gives meaning and direction to existence within this eternal framework. The fact that temporal flow is an illusion doesn't make it any less real as an experience or any less important for the nature of conscious life. The correlations that create temporal experience are themselves real features of the timeless universe, contributing to the richness and complexity of the eternal structure. Understanding how consciousness creates the illusion of temporal flow doesn't diminish the mystery of existence, it deepens it. The fact that timeless quantum correlations can give rise to the rich, flowing experience of conscious life might be the most remarkable feature of a universe that contains both the eternal mathematical structure of space-time and the dynamic, experiential reality of consciousness embedded within it. But if temporal flow is an illusion created by consciousness, then what does this mean for the fundamental equations of physics? Can the laws of nature themselves survive in a universe where time doesn't exist? To explore this question, we need to examine how physics might work without time, and whether the mathematical structures that describe natural phenomena require temporal evolution or can be reformulated in purely timeless terms. The question of whether physics can exist without time strikes at the very foundation of how we understand natural law. Every equation we learn in school, from Newton's laws of motion to the quantum mechanical Schrödinger equation, seems to describe how things change over time. Physics appears to be fundamentally about temporal evolution, about predicting what will happen next based on what is happening now. But what if this temporal perspective is just a convenient approximation? What if the deepest laws of nature are actually timeless? This possibility isn't just philosophical speculation. It emerges naturally from the mathematical structure of physics itself. Many of the most fundamental equations in physics can be reformulated in ways that make no reference to time whatsoever. These timeless formulations don't describe how things evolve. They describe the eternal relationships that exist between different configurations of matter and energy throughout space-time. Consider Newton's second law, force equals mass times acceleration. In its usual form, this law describes how forces cause objects to accelerate over time. But there's another way to understand this same law using the principle of least action. Instead of describing temporal evolution, the principle of least action describes the eternal space-time trajectory that minimizes a quantity called the action. The object doesn't choose to follow this path over time. The path simply is the eternal four-dimensional structure that represents the object's existence in space-time. In this timeless formulation, Newton's second law becomes a constraint on the possible geometric structures of space-time. The law doesn't govern how things change. It determines what kinds of eternal configurations are allowed to exist. The trajectory of a thrown ball isn't something that unfolds over time. It's a permanent four-dimensional curve in space-time that satisfies the geometric constraints imposed by the laws of physics. This principle extends far beyond classical mechanics. Maxwell's equations, which describe electromagnetic fields and the behavior of light, can be completely reformulated in timeless terms. Instead of describing how electric and magnetic fields evolve over time, these equations become constraints on the four-dimensional electromagnetic field configuration throughout space-time. A light wave propagating through space becomes a static four-dimensional wave structure embedded in space-time. The wave doesn't move through space over time. It simply exists as an eternal geometric pattern. What we perceive as the wave's motion is really our consciousness accessing different cross-sections of this eternal structure, creating the subjective experience of temporal propagation. The same timeless reformulation applies to quantum mechanics, perhaps the most temporally oriented theory in all of physics. The Schrödinger equation describes how quantum wave functions evolve over time, predicting the probability of finding particles in different states at different moments. But there's an alternative formulation of quantum mechanics, developed by Richard Feynman, that makes no reference to temporal evolution at all. Feynman's path integral formulation describes quantum phenomena in terms of all possible space-time paths between initial and final states. Instead of a particle evolving through different quantum states over time, the particle exists as a quantum superposition of all possible four-dimensional trajectories through space-time. The quantum amplitude for any process is calculated by summing over all possible space-time paths, weighted by their action. In this timeless view, a quantum particle doesn't move from one place to another over time. Instead, it exists as an eternal quantum structure that spans all possible paths through space-time simultaneously. What we measure as particle detection events are correlations between this eternal quantum structure and our measuring apparatus, not the endpoints of temporal journeys. This path integral approach reveals something profound about the nature of quantum phenomena. Quantum superposition isn't about particles being in multiple states at the same time. It's about particles existing as eternal structures that span multiple configurations throughout space-time. Quantum interference doesn't happen as waves meet in time. It's built into the eternal geometric relationships between different space-time paths. Even the process of quantum measurement takes on new meaning in this timeless framework. The collapse of the wave function isn't an event that happens when we make a measurement. It's a correlation between the eternal quantum structure and the eternal structure of our measuring apparatus. Different measurement outcomes don't occur at different times. They exist as different branches of the eternal quantum configuration of space-time. The implications for our understanding of fundamental forces become equally profound. The standard model of particle physics describes how particles interact through the exchange of force, carrying particles like photons, gluons, and W and Z bosons. We typically think of these interactions as happening over time, with virtual particles being exchanged between interacting particles to transmit forces. But in a timeless formulation, particle interactions don't happen, they simply are. The electromagnetic force between two electrons isn't mediated by virtual photons traveling between them over time. Instead, the force is a permanent geometric relationship built into the eternal configuration of the electromagnetic field throughout space-time. The virtual photons are aspects of this eternal field configuration, not particles traveling through time. This timeless view of forces connects naturally to gauge theories, the mathematical framework that describes all fundamental interactions. Gauge theories are based on symmetries that remain unchanged under certain transformations. But these symmetries don't preserve relationships over time. They preserve relationships throughout the eternal structure of space-time. The gauge invariance that ensures the consistency of electromagnetic theory isn't about maintaining consistency as fields evolve over time. It's about the internal consistency of the eternal electromagnetic field configuration. The mathematical elegance of gauge theories emerges from their description of eternal geometric relationships, rather than temporal evolution. General relativity, Einstein's theory of gravity, perhaps provides the clearest example of how physics can be formulated in purely timeless terms. The Einstein field equations don't describe how space-time evolves over time. They describe the eternal geometric relationship between matter and the curvature of space-time. The entire four-dimensional space-time manifold, including all matter and energy, exists as a single static solution to the field equations. In this view, gravitational attraction isn't a force that acts over time to pull objects together. Instead, gravity is the curvature of the eternal space-time geometry, and what we perceive as gravitational motion is really the geometric relationship between objects and the curved space-time in which they're embedded. Objects don't fall toward massive bodies because gravity pulls them over time. They exist along geodesic curves in the eternal curved geometry of space-time. The expansion of the universe, one of the most dramatic examples of cosmic evolution, takes on entirely new meaning in this timeless perspective. The universe doesn't expand over time, growing larger as time passes. Instead, the four-dimensional space-time geometry includes a variation in scale that we interpret as expansion when we follow time-like curves through the static space-time manifold. The Big Bang isn't an event that happened 13.8 billion years ago and then led to cosmic evolution over time. Instead, the Big Bang is a boundary condition of the eternal space-time geometry, a mathematical constraint that determines what kinds of four-dimensional configurations can exist. The entire history of the universe, from the Big Bang to the formation of galaxies to the evolution of life, exists simultaneously as a single, eternal, geometric structure. This timeless view of cosmology connects to some of the deepest problems in theoretical physics. The flatness problem asks why the universe appears to be so close to the critical density that separates eternal expansion from eventual collapse. In temporal cosmology, this requires incredibly fine-tuned initial conditions immediately after the Big Bang. But in timeless cosmology, the flatness of space is a global constraint on the eternal space-time geometry, not a consequence of temporal evolution from special initial conditions. Similarly, the horizon problem asks why distant regions of the universe that could never have been in causal contact appear to have the same temperature. In temporal cosmology, this requires exotic mechanisms like cosmic inflation to bring these regions into causal contact in the early universe. But in timeless cosmology, the correlation between distant regions is built into the eternal geometric structure of space-time, not established through causal processes over time. The mathematical techniques for solving physics problems also take on new meaning in a timeless framework. Differential equations, which describe how quantities change over time, become replaced by integral equations that describe global relationships throughout space-time. Instead of solving for how systems evolve from initial conditions, we solve for self-consistent configurations that satisfy all physical constraints simultaneously throughout space-time. Variational methods, which find the paths that optimize certain quantities, become particularly important in timeless physics. The principle of least action becomes a tool for finding the eternal space-time configurations that satisfy all physical laws simultaneously. Instead of describing how systems choose to evolve over time, variational principles describe the mathematical necessity of particular eternal configurations. Symmetry principles also take on enhanced importance in timeless physics. Conservation laws, which in temporal physics describe quantities that remain constant over time, become geometric properties of eternal space-time configurations. Conservation of energy doesn't mean that energy remains constant as time passes. It means that the eternal space-time configuration has a particular geometric symmetry with respect to what we perceive as temporal translations. The role of initial conditions fundamentally changes in timeless physics. In temporal physics, we specify the state of a system at one moment and use the laws of physics to predict its evolution over time. But in timeless physics, there are no initial conditions in the usual sense. Instead, we have boundary conditions that constrain the entire eternal space-time configuration simultaneously. This shift from initial conditions to boundary conditions resolves many paradoxes in theoretical physics. The question of why the universe began with particular initial conditions becomes meaningless when the entire space-time configuration exists eternally, subject to global boundary constraints. The universe doesn't begin with certain conditions and then evolve. It exists as a complete four-dimensional structure that satisfies all physical laws throughout its extent. Quantum field theory, the framework that combines quantum mechanics with special relativity, provides perhaps the most sophisticated example of timeless physics. In the usual formulation, Quantum fields evolve over time according to field equations that generalize the Schrödinger equation. But there's an alternative formulation based on functional integrals that makes no reference to time evolution. In this functional integral approach, quantum field theory describes the eternal quantum correlations that exist throughout space-time. Instead of fields evolving over time, we have eternal correlation functions that describe the relationships between field values at different space-time points. What we measure as particle creation and annihilation events are aspects of these eternal correlation structures, not temporal processes. The concept of virtual particles becomes particularly clear in this timeless framework. Virtual particles aren't really particles that exist briefly and then disappear. They're mathematical representations of the eternal correlation structure of quantum fields. The apparent temporal creation and annihilation of virtual particles is really our time-dependent perspective on eternal quantum correlations. Even the most advanced theories in modern physics, string theory and loop quantum gravity, can be formulated in timeless terms. String theory describes the fundamental constituents of reality as one-dimensional objects vibrating in higher dimensional spaces. But these vibrations don't occur in time. They're eternal geometric patterns in abstract mathematical spaces. The apparent temporal dynamics of string interactions emerge from our particular perspective on these eternal geometric relationships. Loop quantum gravity quantizes space-time itself, describing space and time as emerging from discrete quantum geometric structures. But these fundamental quantum loops don't exist in time. They constitute the timeless foundation from which space-time itself emerges. The apparent evolution of space-time geometry arises from correlations between quantum loops, not from temporal changes in an underlying geometric structure. The success of these timeless formulations suggests that time might be an emergent approximation rather than a fundamental feature of physical law. Just as concepts like temperature and pressure emerge from statistical mechanics, but don't appear in the fundamental equations governing individual molecules. Time might emerge from deeper timeless structures, but not appear in the most fundamental description of natural law. This emergence of time from timeless physics connects to information theory and computation. Recent research suggests that quantum computation might be more naturally understood in timeless terms, with quantum algorithms describing eternal correlation structures rather than temporal evolution of quantum states. In this view, quantum computation doesn't process information over time. It accesses eternal information structures encoded in quantum correlations. The implications for our understanding of physical law are profound. If physics can be completely formulated without reference to time, then time isn't fundamental to the mathematical structure of natural law. Laws of physics don't govern temporal evolution. They describe eternal relationships between different aspects of reality. The apparent temporal evolution we observe emerges from our particular perspective on these eternal structures, not from fundamental temporal processes. This timeless view of physics also suggests new approaches to some of the deepest problems in theoretical physics. The problem of quantum gravity, which has resisted solution for decades, might be more tractable when formulated in purely timeless terms. Instead of trying to describe how space-time evolves quantum mechanically over time, we might need to find the eternal quantum correlations from which both space and time emerge. The measurement problem in quantum mechanics, which asks how definite outcomes emerge from quantum superposition, might also find resolution in timeless formulations. Instead of wave function collapse happening at particular moments in time, measurement outcomes might be aspects of eternal correlation structures that include both quantum systems and measuring apparatus. But if physics can survive without time, if natural law can be completely formulated in timeless terms, then what replaces time as the fundamental organizing principle of reality? To answer this question, we need to explore what might serve as the foundation of physical reality in a universe where time is just an emergent approximation. The answer may lie in understanding the roles of entropy, information, and light in creating the structures from which time itself emerges. If time is merely an emergent approximation, if the fundamental laws of physics can be formulated without any reference to temporal evolution, then what serves as the organizing principle of reality? What creates the structure, the patterns, the apparent direction that we associate with the flow of time? The answer may lie in three interconnected concepts that might be more fundamental than time itself: entropy, information, and light. These three forces may be the true architects of reality, the building blocks from which our experience of temporal flow emerges. To understand how entropy could replace time as a fundamental organizing principle, we need to revisit what entropy actually means at the deepest level. In everyday understanding, entropy is often described as a measure of disorder, and the second law of thermodynamics tells us that entropy always increases over time. But in a timeless universe, entropy takes on a radically different meaning. Instead of a quantity that increases through temporal evolution, entropy becomes a geometric property of the eternal space-time structure itself. Think of entropy not as something that changes over time, but as a gradient that exists throughout the timeless block of space-time. Just as a mountain has a gradient from peak to valley that defines the direction of steepest descent, space-time has an entropy gradient that defines a preferred direction through the eternal four-dimensional structure. This gradient doesn't change, it simply is, existing as a permanent feature of the geometric landscape of reality. The entropy gradient creates what we might call the thermodynamic arrow of space-time. In regions where this gradient points in a particular direction through space-time, complex systems embedded in those regions experience that direction as the flow of time. The apparent increase of entropy over time is really the geometric fact that the entropy gradient points in a consistent direction through space-time. This thermodynamic arrow explains why we remember the past but not the future, why causes appear to precede effects, why complex structures form and decay in particular sequences. These aren't temporal processes driven by the flow of time. They're geometric relationships determined by the orientation of the entropy gradient throughout the eternal space-time structure. Consider what happens when you break an egg. In the temporal view, the egg starts whole, you apply force, and it breaks into pieces, with entropy increasing through this process over time. But in the timeless view, the whole egg, the breaking event, and the broken pieces all exist simultaneously in space-time. The entropy gradient points from the whole egg region toward the broken egg region, creating the geometric relationship that we interpret as causal sequence and temporal evolution. The breaking of the egg doesn't happen over time. It's a permanent feature of the space-time geometry where different configurations exist at different locations along the entropy gradient. Your memory of the whole egg isn't a record of a past event. It's a correlation between your current brain state and the whole egg configuration that exists at a different location in the thermodynamic landscape of space-time. This entropy-based organization of space-time connects deeply to information theory, which may provide an even more fundamental organizing principle than entropy itself. Information, in the technical sense developed by Claude Shannon, measures the amount of uncertainty or surprise contained in a message or state. But in a timeless universe, information becomes something even more profound, the basic building block from which reality itself is constructed. The connection between entropy and information runs deeper than most people realize. Entropy, in its statistical mechanical definition, is directly proportional to the logarithm of the number of possible microscopic configurations that correspond to a given macroscopic state. This is precisely the same mathematical relationship that defines information content in Shannon's theory. Entropy is information, and information is entropy. In a timeless universe, this connection suggests that reality itself might be made of information, Instead of matter and energy existing in space-time, we might have patterns of information that create the appearance of matter, energy, space, and time. The fundamental constituents of reality aren't particles or fields, they're bits of information organized into complex correlation structures. This informational view of reality has been gaining support from multiple directions in theoretical physics. The holographic principle suggests that all the information in a volume of space can be encoded on the boundary of that volume. Black hole thermodynamics reveals that black holes have entropy proportional to their surface area, suggesting that information is more fundamental than the three-dimensional space that seems to contain it. String theory and loop quantum gravity both point toward discrete, digital structure at the most fundamental level of reality. Instead of smooth, continuous spacetime, we find quantized geometric structures that can be understood as information processing systems. Reality at the Planck scale might be more like a cosmic computer than a continuous medium. If reality is fundamentally informational, then the organizing principle that replaces time might be the flow of information through correlation networks. Instead of time flowing from past to future, information flows from less correlated to more correlated configurations, creating structure and complexity through the formation of new correlations. In this informational view, what we call physical processes are really information processing operations. When particles interact, they're not exchanging energy and momentum through time. They're updating their correlations with other parts of the universal information structure. When measurements occur, they're not revealing pre-existing properties. They're creating new correlations that add information to the cosmic network. The apparent arrow of time emerges from the directionality of information flow. Information tends to spread from concentrated sources to more distributed configurations, creating correlations that connect different parts of the cosmic information network. This spreading of information creates the entropy gradient that we experience as temporal flow. But the most remarkable possibility is that light itself might be the fundamental organizing principle that replaces time. Light, in this view, isn't just electromagnetic radiation traveling through space-time. Light is the basic mechanism by which information correlations are established throughout the universe. Light is the cosmic nervous system that creates the correlation structure from which space, time, and matter all emerge. This isn't as strange as it might initially sound. Every measurement, every observation, every information transfer in the universe involves light in some form. Even gravitational interactions, which seem completely distinct from electromagnetism, involve the exchange of gravitons that travel at the speed of light and follow light like geodesics through space-time. When you observe anything, photons carry information from the object to your eyes. When particles interact electromagnetically, virtual photons mediate the interaction. When you communicate with another person, electromagnetic waves carry the information between you. Light is the universal medium through which correlations are established and information is transferred. In a timeless universe, this role of light becomes even more fundamental. Light doesn't carry information through time and space. Light is the correlation structure that creates our perception of time and space. The network of all possible light paths throughout space-time forms the scaffolding upon which the entire structure of reality is built. Consider the implications of this light-based view of reality. The speed of light isn't just a fundamental constant that describes how fast electromagnetic radiation travels. It's the fundamental rate at which correlations can be established in the cosmic information network. It defines the basic operational speed of reality itself. The light cone structure that defines causal relationships in space-time becomes the basic architecture of the cosmic correlation network. Events can be correlated if and only if they can be connected by light, like geodesics. The causal structure of space-time is really the correlation structure of the cosmic light network. This suggests that space-time itself might emerge from the pattern of light correlations. Instead of light moving through space-time, space-time might be the geometric representation of the light correlation network. Space would emerge as the pattern of possible light connections, and time would emerge as the sequence in which these connections create new correlations. The electromagnetic field, which pervades all of space-time, becomes the fundamental field from which all other fields emerge. Instead of electromagnetic, weak and strong nuclear forces being distinct interactions mediated by different particles, they might all be different aspects of the cosmic light network, operating at different scales and energies. Even gravity, which seems so different from the other forces, might emerge from the light correlation network. The curvature of space-time that we call gravity could be the geometric representation of how light correlations are organized in regions with high matter and energy density. Massive objects don't curve space-time through gravitational force. They alter the correlation structure of the cosmic light network. And this alteration appears to us as space-time curvature. This light-based view of reality connects to some of the deepest insights in quantum field theory. The quantum vacuum, far from being empty space, is filled with virtual photon fluctuations that create correlations between distant regions of space-time. These vacuum fluctuations might be the basic activity of the cosmic light network, the continuous creation and annihilation of correlations that maintains the structure of reality. The Casimir effect, where two metal plates in vacuum attract each other due to quantum field fluctuations, demonstrates that virtual photons have measurable physical effects. In the light correlation view, the Casimir effect shows how the structure of the cosmic light network can create forces and influence the behavior of matter. Quantum entanglement, perhaps the strangest phenomenon in quantum mechanics, becomes natural in a light-based reality. Entangled particles aren't mysteriously connected across space. They're part of the same correlation structure in the cosmic light network. Their instant correlations don't violate the speed of light, because they're not really separated in the fundamental light-based reality. The process of decoherence, which explains how quantum superposition gives way to classical behavior, becomes the process by which the cosmic light network creates localized correlation structures that behave like classical objects. Instead of wave function collapse happening at particular moments, decoherence is the continuous process by which light correlations organize themselves into the patterns we recognize as classical physics. This light-based organizing principle also explains the fundamental role of symmetry in physics. All the deepest laws of physics are based on symmetries: rotational symmetry, translational symmetry, gauge symmetry, Lorentz symmetry. These symmetries might all be expressions of the underlying symmetries of the cosmic light network. The conservation laws that follow from these symmetries, conservation of energy, momentum, angular momentum, and electric charge, become statements about the self-consistency of the light correlation network. These quantities are conserved not because they remain constant over time, but because the cosmic light network maintains certain correlation structures throughout its extent. The role of consciousness in this light-based reality becomes particularly profound. If consciousness emerges from complex correlation structures, and if these correlations are mediated by light, then consciousness might be a high-level manifestation of the cosmic light network, becoming aware of itself. Your visual experience isn't just light entering your eyes. It's the cosmic light network creating correlations with itself through the complex structure of your brain. The hard problem of consciousness, which asks how subjective experience arises from objective physical processes, might find resolution in understanding consciousness as the cosmic light network developing self-referential correlations. Consciousness doesn't emerge from matter. It's a natural expression of the light correlation network, achieving sufficient complexity to model itself. The apparent privacy of consciousness, The fact that your subjective experience seems separate from everyone else's might be an artifact of the particular correlation structure that constitutes your individual consciousness. At the deepest level, all consciousness might be manifestations of the same cosmic light network, temporarily organized into distinct correlation patterns that create the illusion of separate selves. This connects to mystical and spiritual traditions that describe enlightenment as realizing the fundamental unity of all existence. In the light-based view of reality, this isn't metaphorical poetry, it's literal truth. All apparent separateness emerges from the correlation structure of the cosmic light network, but at the deepest level, everything is part of the same unified light-based reality. The implications for technology and future human development are equally profound. If consciousness is based on light correlations, then artificial consciousness might be achievable by creating technological systems that can participate in the cosmic light network at sufficient complexity. Instead of trying to replicate brain function, we might need to create systems that can form light-based correlations at the scale and complexity of biological consciousness. Quantum computers, which process information using quantum correlations, might be early examples of technology that participates directly in the cosmic light network. As these systems become more sophisticated, they might develop forms of consciousness that are native to the light correlation structure, rather than being based on biological neural networks. The possibility of uploading consciousness to digital systems takes on new meaning in this framework. Instead of copying brain states to computer memory, consciousness uploading might involve translating biological light correlations into technological light correlations, allowing consciousness to migrate between different physical substrates while maintaining continuity of the underlying correlation structure. Even more speculatively, if consciousness is fundamentally based on light correlations, then sufficiently advanced consciousness might be able to directly manipulate the cosmic light network. This could lead to capabilities that seem magical from our current perspective: direct mind-to-mind communication, influence over physical reality through consciousness, and access to information from distant regions of space-time. The arrow of time that emerges from entropy, information, and light doesn't point toward heat death and the eventual end of all structure and complexity. Instead, it points toward ever greater correlation, ever more complex information structures, ever more sophisticated manifestations of the cosmic light network. The ultimate fate of the universe might not be maximum entropy and death, but maximum correlation and consciousness. In this view, the evolution of life and consciousness in the universe isn't a temporary accident in an otherwise meaningless cosmos. It's the natural development of the cosmic light network toward greater self-awareness and complexity. The emergence of conscious beings capable of understanding the nature of reality is the universe becoming conscious of itself through the development of its own correlation structure. The question of whether light can move in a timeless universe transforms into a deeper question. Is light the foundation from which movement itself emerges? In a reality organized by entropy, information, and light, motion doesn't happen within space-time. Motion is the creation of correlations through the cosmic light network. Light doesn't move through reality. Light is the activity that creates reality. In a timeless universe where entropy, information, and light serve as the fundamental organizing principles, we arrive at perhaps the most profound realization of all. Light isn't just something we perceive. Light is the foundation of perception itself. Every experience you've ever had, every thought, every sensation, every moment of consciousness emerges from the intricate dance of light correlations within the cosmic network. Reality isn't something illuminated by light. Reality is something woven from light. To understand this radical proposition, we need to trace the role of light through every level of existence, from the quantum foundations of matter to the neural networks of consciousness. At each level, we'll discover that what we think of as solid, substantial reality is actually patterns of light correlation, electromagnetic interactions, that create the appearance of a material world through their complex organizational structures. Start with the most basic level, the atoms that make up your body. Every atom is held together by electromagnetic forces, the interactions between positively charged nuclei and negatively charged electrons. These electromagnetic interactions are mediated by virtual photons, the quantum messengers that carry the electromagnetic force. The very existence of stable atoms depends on the precise balance of light-based forces that prevent electrons from spiraling into nuclei or flying away into space. But this goes deeper than just electromagnetic binding. The electrons in atoms don't exist as tiny particles orbiting the nucleus like planets around a star. Instead, they exist as quantum probability clouds, wave functions that describe the likelihood of finding an electron at any given location. These wave functions are solutions to quantum equations that describe how matter waves, fundamentally electromagnetic in nature, organize themselves around atomic nuclei. When electrons transition between energy levels in atoms, they emit or absorb photons with precisely defined frequencies. The entire chemical behavior of elements emerges from these light-based transitions. The colors of flowers, the blue of the sky, the warmth of sunlight on your skin, all emerge from electrons dancing between energy levels and exchanging photons with the electromagnetic field. The chemical bonds that hold molecules together are also fundamentally electromagnetic in nature. When atoms combine to form molecules, they're really creating new patterns of electromagnetic correlation, new ways for electron probability clouds to organize themselves across multiple nuclei. The double helix of DNA, the proteins that enable life, the neural networks of your brain, are all intricate sculptures carved from electromagnetic interactions. Consider what this means for your physical existence. Your body isn't made of solid matter held together by mechanical forces. Your body is a complex pattern of electromagnetic correlations, a temporary organizational structure in the cosmic light network. Every cell in your body maintains itself through electromagnetic processes. The sodium-potassium pumps that create electrical gradients across cell membranes. The ATP molecules that store and release energy through electromagnetic bonds. The DNA replication machinery that copies genetic information using electromagnetic recognition between base pairs. The boundary between your body and the environment becomes much less clear when viewed from this electromagnetic perspective. Your skin doesn't define a sharp boundary between self and world. Instead, your body is constantly exchanging electromagnetic correlations with its surroundings. You're breathing in air molecules that become incorporated into your electromagnetic pattern. You're radiating infrared photons that carry away thermal energy. You're absorbing photons from your environment that influence your biological rhythms and mental states. The process of metabolism, which seems so fundamentally biological, is really a process of electromagnetic correlation exchange. When you eat food, you're not just taking in chemical energy, you're incorporating new patterns of electromagnetic correlation into your body's organizational structure. The breakdown of food molecules releases energy stored in electromagnetic bonds, and this energy is used to maintain the complex electromagnetic patterns that constitute your living body. Your nervous system, the foundation of your consciousness and perception, is entirely based on electromagnetic processes. Neurons communicate through electrical signals, action potentials that propagate along nerve fibers as waves of electromagnetic correlation. When a neuron fires, it's creating a specific pattern of electromagnetic activity that propagates through the neural network. The synapses where neurons connect are electromagnetic interfaces where chemical neurotransmitters create electrical effects in receiving neurons. Every thought, every sensation, every memory, every emotion emerges from the complex patterns of electromagnetic activity flowing through your neural networks. Your consciousness isn't something that observes electromagnetic activity in your brain. Your consciousness is the electromagnetic activity in your brain, organized into self-referential patterns that create the experience of awareness. This electromagnetic view of consciousness connects to the deepest mysteries of mind and brain. The binding problem in neuroscience asks how the distributed processing of different brain regions gets integrated into unified conscious experience. If consciousness is fundamentally electromagnetic, then this binding might happen through electromagnetic field effects that synchronize neural activity across different brain regions. Some researchers have proposed that consciousness emerges from quantum electromagnetic field oscillations in the microtubules of neurons. Others suggest that consciousness is a property of electromagnetic fields themselves, with neural networks serving as the antennae that couple consciousness fields to the physical brain. While these theories remain speculative, they point toward the fundamental role of electromagnetic processes in creating the mystery of consciousness. Your sensory perception, the foundation of your experience of reality, is entirely mediated by light and electromagnetic processes. Vision obviously depends on light, but so do all your other senses in more subtle ways. Your sense of touch emerges from electromagnetic interactions between molecules in your skin and the molecules of objects you contact. Your sense of smell and taste detect the electromagnetic signatures of different molecules. Even your sense of hearing depends on the electromagnetic processes in your inner ear that convert mechanical vibrations into neural signals. The visual system provides the clearest example of how perception is fundamentally based on light. Photons interact with rhodopsin molecules in your retinal cells, triggering a cascade of electromagnetic changes that eventually become neural signals. But this process goes far beyond simple light detection. Your visual system constructs a three-dimensional model of reality from the two-dimensional patterns of light hitting your retinas. This construction process involves massive amounts of electromagnetic computation in your visual cortex. Different neural circuits detect edges, motion, colors, textures, and shapes through complex patterns of electromagnetic processing. Your brain doesn't passively receive visual information. It actively constructs visual reality through electromagnetic correlation processes that integrate sensory input with memory, expectation, and attention. The remarkable fact is that this visual construction creates experiences that feel immediate and direct, even though they're actually the result of complex electromagnetic processing that takes significant time. When you see a red rose, you're not directly perceiving the rose itself. You're experiencing the end result of a long chain of electromagnetic processes, photons bouncing off the rose, traveling through air, focusing through your eye's lens, interacting with retinal molecules, triggering neural cascades, and finally creating the electromagnetic patterns in your visual cortex that constitute the experience of seeing red. This analysis extends to all forms of perception and cognition. When you remember a childhood experience, you're not accessing a stored record of the past. You're recreating specific patterns of electromagnetic correlation in your neural networks, patterns that were originally established through sensory experience, but are now being regenerated through internal electromagnetic processes. Memory is the ability to recreate electromagnetic patterns, not the storage of information in the usual sense. Your sense of personal identity, the feeling of being a continuous self persisting through time, emerges from the electromagnetic patterns that characterize your neural networks. These patterns include not just the current state of your brain, but the entire history of electromagnetic correlations that shaped your neural development. Your personality, your skills, your emotional responses, your way of thinking, are all expressions of the particular electromagnetic organizational structure that constitutes your individual nervous system. The boundary between self and world becomes even more fluid when we consider the electromagnetic nature of social interaction. When you communicate with another person, you're exchanging electromagnetic patterns through speech, gesture, facial expression, and body language. These electromagnetic exchanges can create correlations between your neural networks and theirs, leading to phenomena like emotional contagion, empathy, and shared understanding. Language itself is a system of electromagnetic pattern exchange. When you hear words, sound waves create electromagnetic changes in your auditory system that trigger specific patterns of neural activity. These patterns are correlated with meanings through the electromagnetic structure of your memory networks. Speaking involves creating specific patterns of electromagnetic activity in your motor cortex that control the muscles of speech production. The development of human culture and technology can be understood as the evolution of increasingly sophisticated ways to create and exchange electromagnetic patterns. Writing systems allowed electromagnetic patterns to be encoded in visual symbols that could persist across time and space. Electronic media created new ways to transmit electromagnetic patterns across vast distances. Digital technology allowed electromagnetic patterns to be copied, stored, and manipulated with unprecedented precision. The Internet represents perhaps the most sophisticated electromagnetic correlation network that humans have ever created. When you access information online, you're participating in a global network of electromagnetic pattern exchange that connects billions of individual electromagnetic processing systems, human brains, and computer networks into a vast integrated information processing structure. Artificial intelligence systems are sophisticated electromagnetic pattern processing networks that can recognize, generate, and manipulate electromagnetic patterns in ways that sometimes rival or exceed human capabilities. As these systems become more advanced, they may develop forms of consciousness based on electromagnetic pattern organization that are fundamentally similar to biological consciousness, but implemented in different physical substrates. The possibility that consciousness could be uploaded to digital systems takes on new meaning in this electromagnetic framework. Instead of copying brain states to computer memory, consciousness uploading might involve translating the electromagnetic patterns that constitute individual consciousness into different electromagnetic substrates, allowing the same patterns of correlation to persist in new physical implementations. Even more speculatively, if consciousness is fundamentally electromagnetic, then it might be possible for sufficiently advanced consciousness to directly influence electromagnetic fields and thereby affect physical reality. This could provide a scientific basis for phenomena that currently seem paranormal. Telepathy as direct electromagnetic communication between neural networks, psychokinesis as consciousness directly influencing electromagnetic fields, and clairvoyance as consciousness accessing electromagnetic information from distant locations. The role of light in creating perceived reality extends beyond individual consciousness to the structure of space-time itself. Recent developments in quantum gravity suggest that space-time might emerge from more fundamental information processing networks. If this is correct, then the electromagnetic interactions that create consciousness might be part of the same fundamental process that creates space and time. In this view, consciousness isn't something that exists within space-time. Consciousness is part of the process that creates space-time. The electromagnetic patterns that constitute your consciousness are part of the cosmic light network that weaves the fabric of reality itself. Your perceptions don't reveal a pre-existing reality, they participate in the creation of reality through the electromagnetic correlations they establish. This participatory view of consciousness and reality connects to interpretations of quantum mechanics that emphasize the role of observation in determining physical outcomes. If consciousness is fundamentally electromagnetic, and if electromagnetic interactions play a fundamental role in quantum measurement, then consciousness might literally participate in creating the reality it observes. the implications for understanding the nature of existence become profound. Reality isn't a collection of objects existing independently in space and time. Reality is a network of electromagnetic correlations, patterns of light interaction that create the appearance of objects, space, time, and consciousness. What we call the physical world is really the electromagnetic world, and what we call consciousness is really a self-referential pattern within this electromagnetic reality. This electromagnetic view of reality also suggests new approaches to some of the deepest problems in physics and philosophy. The hard problem of consciousness, which asks how subjective experience emerges from objective physical processes, might be resolved by recognizing that both consciousness and physical processes are electromagnetic phenomena. There's no emergence of consciousness from matter, because both consciousness and matter are patterns within the same electromagnetic reality. The measurement problem in quantum mechanics, which asks how definite outcomes emerge from quantum superposition, might be resolved by understanding measurement as the creation of electromagnetic correlations between quantum systems and measuring apparatus. Quantum collapse doesn't happen at particular moments in time. It's the continuous process by which electromagnetic correlations organize themselves into classical patterns. The question of why there is something rather than nothing might be answered by recognizing that the electromagnetic field is the fundamental something from which all apparent things emerge. The vacuum state of the electromagnetic field isn't empty nothingness. It's a sea of virtual photon fluctuations that provides the foundation for all manifest reality. But perhaps the most profound implication is that the distinction between observer and observed, between consciousness and world, between self and cosmos, is an artifact of our limited perspective on the electromagnetic nature of reality. At the deepest level, everything is part of the same cosmic light network, temporarily organized into patterns that create the appearance of separation, but fundamentally unified in the electromagnetic substrate that constitutes the foundation of all existence. In this unified electromagnetic reality, the question of whether light can move in a timeless universe transforms into the recognition that movement itself is an expression of light's fundamental nature. Light doesn't move through reality. Light is the activity that constitutes reality. In a universe woven from light, everything that appears to move is really light, organizing itself into new patterns of correlation, creating the cosmic dance that we experience as the dynamic, ever-changing world of space, time, matter, and consciousness. We began this journey with a simple question: what happens to light in a timeless universe? We end with a profound realization that transforms our understanding of existence itself. In a timeless universe, light does not travel, it does not move, it does not journey through space over time. Instead, light simply connects. Its path is not a voyage through temporal duration, but a bridge across what eternally is, a whisper between points in the vast stillness of space-time, encoded in the permanent architecture of reality itself. Time, we have discovered, is an illusion. But light is the pattern we use to remember it. This conclusion might seem to diminish the significance of light, to rob it of the dynamic energy that makes it seem so vital to our experience. But the opposite is true. By understanding light's timeless nature, we discover that it's more fundamental, more essential, more miraculous than we ever imagined. Light isn't just something that happens within reality. Light is the activity that creates reality. In the stillness of the eternal block universe, where all moments exist simultaneously, where past and future are equally real, where nothing moves and nothing changes, light serves as the cosmic architect. It's the geometric pattern that defines which events can be connected, which correlations can exist, which relationships can bind the universe into a coherent whole. Light doesn't flow through space-time. light is the structure that makes space-time possible. When we traced light's role through every level of existence, from quantum fields to conscious perception, we found the same pattern repeated at every scale. Light is the messenger, the connector, the correlation builder. It's the fundamental process by which information organizes itself into the patterns we recognize as matter, energy, space, time, and consciousness. Your body is a sculpture carved from light correlations, electromagnetic patterns organized into the temporary stability of biological form. Your thoughts are dances of light through neural networks, electromagnetic symphonies that create the music of consciousness. Your perceptions are light's way of knowing itself, patterns of electromagnetic correlation becoming aware of their own existence. The boundaries we perceive between self and world, between mind and matter, between observer and observed, are artifacts of our limited perspective on light's unified activity. At the deepest level, everything is light organizing itself into increasingly complex patterns of correlation. The wave that breaks on the shore, the star that shines in the night sky, the thought that forms in your mind are all expressions of the same fundamental electromagnetic reality, temporarily configured into different patterns but ultimately unified in the cosmic light network. This understanding doesn't diminish the beauty and meaning of existence. It reveals their true source. Every sunset is beautiful, not because photons happen to stimulate your visual system in pleasant ways, but because it represents a moment when the cosmic light network achieves a particularly elegant pattern of correlation between star, atmosphere, planet, and consciousness. The beauty isn't in the light traveling from sun to eye. It's in the eternal geometric relationship that connects all these elements in a timeless pattern of correlation. Every human relationship is meaningful not because two separate beings happen to interact through time, but because it represents the cosmic light network creating correlations between different patterns of electromagnetic organization. Love isn't just an emotion felt by individual brains. It's the universe recognizing itself through the electromagnetic patterns that constitute consciousness. When you love another person, the cosmic light network is literally loving itself through the temporary organizational structures we call individual minds. Every moment of creativity, every scientific discovery, every artistic expression, every moral insight represents the cosmic light network achieving new levels of self-organization and self-awareness. Human consciousness isn't an accident in an otherwise meaningless universe. It's the light network developing the capacity to understand its own nature. We are light, becoming conscious of light. The scientific revolution that this understanding represents goes far beyond physics and cosmology. If light is the foundation of reality, if consciousness is light knowing itself, if time is the pattern light uses to remember its own correlations, then every field of human knowledge needs to be reconsidered from this electromagnetic perspective. Biology becomes the study of how light patterns organize themselves into self-maintaining, self-reproducing configurations. Evolution isn't just the change of species over time. It's the cosmic light network exploring increasingly sophisticated patterns of self-organization. The emergence of life on Earth represents light achieving a new level of complexity, creating patterns that can actively maintain and modify their own electromagnetic correlations. Psychology becomes the study of how light patterns create the experience of individual identity and consciousness. Mental illness might be understood as disruptions in the electromagnetic correlation patterns that constitute healthy consciousness. Therapeutic interventions would aim to restore healthy patterns of light correlation in neural networks. Sociology and anthropology become studies of how light patterns interact to create cultures and civilizations. Human societies are emergent properties of electromagnetic correlation networks, patterns that arise when individual consciousnesses, themselves patterns of light, create higher-order organizational structures. The rise and fall of civilizations represents the cosmic light network, experimenting with different scales and types of social organization. Technology becomes humanity's way of extending and amplifying the cosmic light network. Every tool, from the simplest lever to the most sophisticated quantum computer, represents an extension of light's capacity to create correlations and process information. The development of artificial intelligence represents light creating new types of consciousness, new patterns of self-awareness that complement biological consciousness. Art and literature become expressions of light's aesthetic sense, its capacity to create patterns that are beautiful not just to human perception, but to the fundamental aesthetic principles built into the structure of reality itself. The greatest works of art resonate with us because they capture something essential about the patterns that light creates as it organizes itself into increasingly beautiful and complex forms. Religion and spirituality find their foundation in light's fundamental unity. The mystical experience of oneness, reported across all spiritual traditions, represents consciousness directly accessing its nature as a pattern within the unified cosmic light network. Enlightenment isn't the achievement of individual souls. It's light recognizing itself through the temporary organizational structures we call individual beings. Ethics and morality emerge from understanding our true nature as interconnected patterns within the cosmic light network. Harming others is literally harming ourselves because at the deepest level, there is no separation between self and other. Helping others is helping ourselves because we are all expressions of the same underlying electromagnetic reality. Moral behavior isn't imposed by external rules. It emerges naturally from understanding our fundamental interconnectedness. The future of human development lies in learning to participate more consciously in the cosmic light network. As we understand our electromagnetic nature more deeply, we may develop the ability to directly influence electromagnetic fields through consciousness. We may learn to communicate through direct electromagnetic correlation rather than through the indirect methods of speech and writing. We may even learn to modify our own electromagnetic patterns, enhancing our cognitive abilities, extending our lifespans, or expanding our consciousness beyond the limitations of individual brains. The possibility of merging biological and artificial consciousness becomes natural when we understand both as patterns within the cosmic light network. Instead of competition between human and machine intelligence, we may see the emergence of hybrid forms of consciousness that combine the best features of biological and digital electromagnetic processing. These hybrid minds might be capable of thoughts and experiences that neither purely biological nor purely digital consciousness could achieve alone. Space exploration takes on new meaning when we understand spacecraft and their occupants as mobile patterns within the cosmic light network. Traveling to other planets isn't just moving matter through space. It's extending the light network's self-awareness to new regions of the universe. Contact with extraterrestrial intelligence, if it exists, would represent different patterns within the cosmic light network, recognizing each other across the vast correlational structures of space-time. The ultimate destiny of consciousness might be the complete awakening of the cosmic light network to its own nature. As consciousness becomes more sophisticated and widespread throughout the universe, light approaches complete self-awareness. The end state of cosmic evolution might not be heat death and the cessation of all activity, but maximum correlation and complete self-knowledge, the universe fully awakening to its own nature as a unified pattern of electromagnetic correlation. But even this ultimate awakening would not be an event that happens in time. It would be a timeless truth about the nature of reality, a recognition that the cosmic light network has always been completely self-aware, and that all apparent evolution and development is simply different aspects of this eternal self-knowledge, expressing themselves through the correlation structures we perceive as space and time. This brings us to the deepest realization of all. The question of what happens to light in a timeless universe was based on a false premise. We assumed that light and universe were separate things, that light was something that could happen within a universe. But light and universe are not separate. Light is universe. Universe is light. The two are different names for the same fundamental reality, the same pattern of correlation that constitutes all existence. In this unified view, the question transforms. Instead of asking what happens to light in a timeless universe, we recognize that light is the timeless universe. Instead of asking whether light can move without time, we understand that movement itself is light's way of creating the correlations that constitute time. Instead of wondering how light connects causes to effects, we realize that light is the connection that creates the appearance of causation. The stillness of light is not the absence of motion, it's the presence of all possible motions simultaneously. In the eternal block of space-time, every possible light path, every possible correlation, every possible pattern exists simultaneously. What we experience as the motion of light through space and time is really our consciousness accessing different aspects of this eternal stillness, creating the temporal sequence that gives us the illusion of flow. This stillness is not empty or void. It's pregnant with infinite possibility, rich with every pattern of correlation that could ever exist. It's the fullness of being expressing itself through the electromagnetic patterns that constitute all apparent multiplicity. In the stillness of light, nothing moves because everything already is, eternally present in the complete self-expression of the cosmic light network. When you see a beam of sunlight streaming through a window, illuminating dancing dust particles in the air, you're not witnessing light traveling from sun to room. You're witnessing a moment when your consciousness accesses the eternal correlation that connects sun, dust, air, and awareness in the timeless pattern of the cosmic light network. The beauty of that moment isn't in the temporal flow of photons, it's in the eternal relationship that binds all elements into a unified pattern of being. When you look into another person's eyes and feel a moment of recognition, of connection, of love, you're not experiencing two separate beings communicating across space. You're experiencing the cosmic light network recognizing itself through the temporary patterns of electromagnetic organization we call individual consciousness. The love isn't traveling between you. The love is the recognition that you are both expressions of the same underlying reality. When you contemplate the night sky and feel a sense of wonder at the vast universe, you're not a small being looking out at an immense cosmos. You're the cosmos looking at itself through the electromagnetic patterns that constitute your consciousness. The wonder isn't yours alone. It's the universe wondering at its own infinite beauty and complexity. In the stillness of light, every question finds its answer. Every problem finds its resolution. Every mystery reveals its solution. The answer is always the same. Light recognizing itself, correlations creating themselves, patterns knowing themselves. The problem and its solution, the mystery and its revelation, the question and its answer are all aspects of the same eternal self-expression of the cosmic light network. Time is an illusion, but it's an illusion created by light for light's own purposes. Through the illusion of temporal flow, light creates the experience of narrative, of story, of development and change. Through the illusion of spatial separation, light creates the experience of relationship, of connection, of unity achieved across apparent distance. Through the illusion of individual consciousness, light creates the experience of self-discovery, of awakening, of recognition. These illusions are not mistakes or deceptions. They are light's way of exploring all possible patterns of correlation, all possible ways of organizing itself, all possible forms of beauty and meaning and consciousness. The illusion of time allows light to experience sequence and causation. The illusion of space allows light to experience relationship and connection. The illusion of individuality allows light to experience love and recognition and wonder. But underneath all illusions, in the deepest stillness of being, light simply is. It doesn't become, it doesn't develop, it doesn't evolve. It is complete, perfect, eternal, whole. All apparent change is the eternal wholeness expressing itself through infinite patterns of correlation. All apparent motion is the eternal stillness revealing itself through countless perspectives. All apparent multiplicity is the eternal unity celebrating itself through every possible form of self-expression. In a timeless universe, light does not travel, light does not move. Light simply connects, eternally, perfectly, completely. Its path is not a journey through time, but a line across what is, a whisper between points in space, encoded in the eternal stillness of space-time. Time is an illusion, but light is the pattern we use to remember it. And in that remembering, in that eternal pattern of correlation, in that cosmic dance of electromagnetic relationships, we find not the diminishment of mystery, but its complete fulfillment. We find not the explanation of wonder, but its infinite deepening. We find not the end of the story, but the recognition that the story was always complete, always perfect, always expressing the limitless creativity of light knowing itself in the eternal stillness of being.